So welcome everybody to this second day of MEC webinars. And since Droidcon Italy was launched in 2014 by Synesthesia, the hackathon has been an important part of the event. Of course, since the hackathon has become a lot more well-known and more familiar in the market, we will still think they are an important way to explore new ideas, build teams, learn new skills in a really hands-on way. So this year we have a great pleasure to work with a lot of great companies like Cisco, Intel, Team, Lynx, Equinix, GSMA, Etsy, and Edge Computing Board. And this hackathon is very particular because it's fully remote, and the teams started to build their projects months ago, and the theme, the technical challenge of this MEC Hackathon is multi-access edge computing. Multi-access edge computing can serve many key in 5G use cases, and most of them are related to application scenarios specifically targeted to vertical markets on the 5G era. And the purpose of this hackathon is to demonstrate the usage of MEC system as an enabler for different use cases and business objectives, helping all stakeholders to develop a diverse open MEC ecosystem. So Dario, I leave you the ball. You can explain better the technical challenge.
Yeah, thank you very much, Francesco. This is the second day of the hackathon, and I have the pleasure to explain this great effort that we made together to attract developers in different areas. Indeed, edge computing can have an impact on many aspects. You can see here in the slides many vertical market segments, and we are asking developers to design and develop their applications in MEC-enabled 5G networks running on openness platform and using MEC technologies. So this is indeed a very nice environment provided. I hope now you can see better in presentation mode. And importantly, we would like to offer also possibly last minute registrants. Up to 2 teams can also enjoy. We are offering also remote server participation and access to the servers. Yesterday we had a set of huge, nice tutorials, and also today there will be a lot of keynote speakers and tutorials and final panel discussion. So you can also learn maybe, hopefully, from this day 2 of the hackathon. And if you are interested, guys, to have access to the servers and, let's say, touch in practice what's about, you can contact us, and we will see what we can do to support you also this second day. So let me also quickly reintroduce all the jury members that are here doing a great effort, and also the whole committee, hackathon organizing committee members that are part of this organization for the hackathon. It's really a joint effort between all those companies, Intel, Cisco, Team, Lynx, Equinix, and with endorsement of the Etsy, the support of GSMA, and the patronage of Città di Torino, and of course the event owner Synesthesia. This is really a joint effort of many people, and this is very nice collaboration. So thanks to everybody again. Let me also mention, Francesco, maybe you can talk better about what is the contribution from Synesthesia, but we have designed a set of attractive prizes for the award ceremony. Maybe you can tell better about Synesthesia.
Yes, Dario. Synesthesia, the host, with Intel and Cisco, will offer for the winning team passes for the future Droidcon conference. Hopefully it will be live in Turin. So all the winning team will be invited to Droidcon to follow the 2 days of conference. And we will offer a prize consisting in the swag bag containing all the t-shirts of Droidcon Italy and many other stuff offered by the sponsors. And
sure. Yeah, from Intel side, I can just add we will offer the possibility to join the Intel Software Innovation Program, and also let's say some other nice prize will be offered to the winner. Special prize are also maybe related to the possible usage of the toolkits like OpenVINO, DPC++. And last but not the least, we mentioned also yesterday, and we will see this afternoon a keynote speaker from the city of Turin, and talking about the Smart Road project. Let me mention there will be the possibility to participate for the winners to the Smart Road project. This is a consortium of partners from car makers, network operators, universities, the city of Turin, with the aim of proposing their developed solution as a possible implementation for testing activities in the urban environment of Turin. So I think this is also a very nice opportunity, complementing the other prizes offered, right, Francesco?
Yes. Absolutely.
Yeah. Cool. So let me quickly recap on the agenda. Okay, maybe not so much on the day one, but the format is the same. We have two tracks. Track number one, which is a public event, and track number two, which is private, only for developers and the organizing committee. So let's follow this live streaming now. We are also recording the event and plan to release a public link for offline watching, also for people that cannot see due to different time zone, or maybe also Thanksgiving's holidays. This is the situation is not possible for everybody to watch live, but of course we will do our best to permit also people to see offline the event. And let's focus on the agenda for today. Today is the second day. Let me read. This is also in our hackathon website. There will be now in a couple of minutes a contribution, a keynote from Alessandro Breccia from Cisco on edge computing overview. And then there will be another tutorial session from Links Foundation, from Maurizio Floridia, on MEC Location API, more technical contribution. And then on a MEC Federation, a standards overview from Masaki Suzuki from KDDI, a keynote. And then after the lunch break, we will have some keynotes and ecosystem panels. So Edge Cloud and Innovation on Automotive, the Smart Road project in Torino City Lab from Nicola Faronato, and then Edge Computing Implementation, the Telco Viewpoint from Andrea Laganà from Telecom Italia, and then Operator Platform from Faisal Zia from GSMA, and MEC for Auto from Leonardo Gomez from Intel, and also Vice Chairman of FGA Working Group 1 on Edge Computing for Automotive. And then a keynote from Juan Carlos Garcia Lopez from Telefonica on Telco Edge Cloud Task Force. And finally, a keynote on MEC Federation Solutions from Himanshu Singh from Altran. And then I will have the pleasure to moderate a panel discussion on business opportunities offered by Edge Cloud for the automotive and other industry segments, with a lot of keynote speakers. And this will finally close the session, and also day two, and also this hackathon event in the final panel. we will close this, but of course this will be just one step, because the final step will be, of course, the celebration of the awards in the main Droidcon conference. Okay, so let me invite you to stay connected and especially to take part to the final keynote and discussion, and feel free to ask any questions to the speakers. Just few recommendations before leaving. We have already assisted to intermediate delivery from the developers. Now there is the final delivery foreseen for the hackathon developers this afternoon. And there will be, of course, the final jury evaluation. The developers are requested to upload their material in our private WebEx area with the PowerPoint slides, presentation, video clip, everything they feel is relevant to present their achievements. And of course, there will be a winner celebration on 27 November, so tomorrow. So yeah, of course, we are assisting you during all the competition. Any question, don't hesitate to ask. And so now is the time to start the second day of this MEC Hackathon. So enjoy the coding, and of course, let's follow the tutorials in live streaming. This track number 1. Thank you so much, guys.
Thank you, Dario. Thanks to all the teams participating.
Okay, now I think the floor is yours. Alessandro, you are already connected.
I'm connected.
Thank you so much.
Thanks, Dario, and thanks, Francesco, for your introduction. So let me start the content. Let me share the content. Okay, I guess you can see it. So first of all, good morning to everyone. I am Alessandro Brescia. I work in Cisco for 15 years or something more now. I am the CTO for our pre-sales operations for the Italian SP, Italian service providers. So in my role, I used to work on the technology. I take care of almost all the Cisco portfolios that you may guess is quite large. And among all the subjects, the edge computing is definitely one of the most interesting and even promising for the next future. So we touched, so the edge is at the heart of our discussion for these 2 days. And we saw that, we see the chance even today to see that there is a lot of technology options, very interesting technology options. But along with the technology, there is there's also a question behind, that is about who is going to invest, who is going to build the edge, who is going to pay for it at the end of the story. Since we want to get closer to the end users, we want to create an infrastructure. But the more we get closer to the end users, and the larger is the investment that is required, since we are talking of a more dense infrastructure. Everyone is going to approach this investment with a very pragmatic way. I would say very opportunistic, in the sense that I invest only where I see a return of the investment, and we may discuss about the time of this return of the investment. But at least for the first phase, we foresee a very pragmatic approach to this investment. And it's clear that the edge is supposed to enable a new set of services for end users, and so the end users that will consume these services will pay for it at the end of the story. But this new revenue stream, this new market, will be shared across a number of players, since edge is not going to be provided by a single player. And as we're going to see with the next few slides, it's a quite complex environment with many players. And it will be interesting to see which will be the dynamics across technology players in order to provide best solutions for the end users. So having said that, let me start from this first slide. Let me put it in presentation mode. It's quite simple slide, but here we want to describe what we are all witnessing. So you can see that we still are in a kind of binary model environment. So there is a service that is provided to and is consumed by end users, and this happens throughout a wire. It may be even a kind of dump pipe. This is where the service providers are, and this is the model that we saw for many years now, and the model where there was this muscular discussions between over the top and service providers. It's about the dump pipe, it's about the network neutrality. It's a word that we know. And what is going on? As we all know, applications are getting more and more complex. And they are getting more complex in the way they consume cloud for the backend mainly, and they span across private cloud or public cloud. And when it gets to public cloud, they consume infrastructure, they consume a platform, they may consume services offered as a service by and from many cloud providers in a truly multi-cloud environment. But this is more the backend of these new kind of applications or services. But when it gets to the front end, the way these applications work with the end users and how they provide value to the end users. So we start to see that these applications may consume a new kind of infrastructure, a kind of a continuum from the cloud to the edge infrastructure in order to provide this new set of services for potential end users. And we're going to touch with the next slides the benefits that this edge infrastructure is supposed to provide. But if we look within this edge, we were saying before, who is going to invest on this edge? It's clear that the expectation is that operators will play a key role here for a couple of reasons. First, operators, service providers, they already provide the access for end users, and it can be a wireline access like fiber. It can be a wireless access, mobile access, like with 4G or the new 5G. And they have an infrastructure behind that access. They have a network, they have sites, they have pods. And in these pods, in this point of presence at the end, they can host infrastructure from third party, or they can create their own infrastructure and host applications. And so value created by third parties, or they can create their own services and sell them directly to the market, to the consumer, or to the business space. So it's clear that there is this expectation that operators, carrier will play a key role here. So we are talking of a kind of a carrier edge. But this is an edge that is maybe implemented in the network, so a kind of on-net edge. Along with this on-net edge, we see interest from even for many kind of off-net edge. Since a big enterprise, but even a small enterprise, they may decide to create infrastructure, computing infrastructure, and host application on-prem, maybe for an industrial plant, or even on top of a car. It can be close to a street for some transportation application. So there is along with the on-net edge, with the carrier edge, there will be an off-net edge, an enterprise edge, let me say a vertical edge, that by the way may be provided by the operator as well, or may be created by the enterprise. And there is a third actor that is worth to mention. That is the cloud, that are the cloud providers, since we all know that they are already creating technology and selling technology to move their services close to the edge, and so close to the end users. We know if we talk of the biggest cloud providers like Google with Anthos, AWS with Outpost, Azure with Edge. So they are all working to create infrastructure, software, services that they may sell on-prem, so directly to the end users, or they can be hosted in the operator's network, and they want to create this hybrid cloud connection, so a bridge between this remote implementation and the cloud services implemented from the central clouds. So at least three kinds of edge: an enterprise, cloud, and carrier edge. In the next few slides, we will focus almost on the carrier edge. So what is the role of the operators? And let me spend a few words on the benefits that the edge may provide to a new set of services. This is something we already touched in our speeches yesterday. I think we will touch it even today. So I'm not going to stay on this slide too much. But it's important to share that Edge is going to provide unique benefits to specific applications. So it means that services and so applications that enable these services may require different, they have different asks from the Edge infrastructure. And this is not, so from a point of view, it gives an idea of how much powerful this new layer can be, but at the same time, it may turn to be even a challenge, since based on the specific applications, you may require to have different edge implementation in a different place, or even a different kind of implementation. Since, just to make a simple example, if I talk about content distribution, I need to have an edge that is storage oriented, since I have to store data. If I talk of maybe in the same segment, so I'm talking of media, but not on demand. But if I look at the live streaming, it's something that is more CPU consuming, since I have to stream towards a huge number of end users, and at the same time. So this is more CPU oriented, CPU driven. So adding a different ask and as well a chance to provide different benefits pose even a question about a challenge, let me say, about how I create a common infrastructure for it. But having said that, as we all know, we have benefits in terms of latency, in terms of capacity optimization. If I look at the downstream for the content distribution, software distribution of the upstream, for a number of services where there's no need to sell something to the cloud, but I can easily providing a better quality of experience doing my local computation, as well as a number of benefits connected with the location, like data that is at the heart of our discussion today, since they are data with a very powerful value, but at the same time with a local significance that may be provided by a MEC platform to specific application running on top of this edge. But the proximity itself is a real value, since, just to make an example, smart cities, that at the end is really about getting data from citizens, doing some kind of elaboration and providing an output. So it's clear that this kind of elaboration may happen everywhere in the world. There is no, it can be quite asynchronous, or let's say, in a way that can be managed from everywhere. But having that data close to the place where the things happen, and close to the citizen in that case, is a real value that we all can sell to in smart city environments to municipalities. So there's a real value about the proximity. So as I say, let's focus on the carrier edge, so the edge provided by the operator. And first of all, we have to introduce a concept, since a user for an operator is a subscriber. Since before getting access to any kind of service, even before getting access to the internet, to the web, a user has to become a subscriber. So operators have to authenticate and authorize And so we are talking about identity, we are talking about policy, what I'm supposed to do based on my contract. I'm talking about charging, about any regulatory obligation like lawful intersection, just to make an example. So this is the space, this is the live operators. And this happens with both the wireline access and as well as with the wireless access, the 4G or the new 5G, and with all the former radio mobile generations. And in order to provide this kind of telco functions at the end of the story, operators have to implement this set of functions. And this has to happen, and this is what our segment wants to do today. This has to happen before the service. So an user has to become a subscriber, and once is a subscriber for an operator, who can get access to service. So to the real heart of the discussion, so what we touched so far. And so services is the place where use cases are implemented, where applications can run in order to provide value. And if I look at this, at the services pillar, and the way a carrier can play a role whether in relation to this carrier edge, this application, we can identify two different approaches that are not mutually exclusive, since they can live at the same time, maybe for different applications. And I think that we all have experience of operators doing both the two approaches. You can see at the left of the slide an approach that is more where the carrier is an enabler, where they host infrastructure or even services and so value provided by someone else, by a third party. And if we move to the right of the slide, we see that the carrier may get a role of a real service provider. So when they are the one selling the value, it could be for business solution, it could be for consumer application, selling directly the value, maybe created by an ecosystem, since we all know that operators may not have all the expertise to address the complexity of specific segments. If I talk of vertical assistance, it's clear they have to create an ecosystem of value, but at the end they can provide and sell that value to the end user, to the vertical assistance, for vertical enablement, for digital transformation. So you can see you can see this two double role, like moving from hosting or selling directly services to the end users. And this, again, these two approaches are not mutually exclusive. They can be truly concurrent, even in the same point of presence. Sorry, and in between, you see. Operators can provide infrastructure or even platform to support third-party applications like or MEC applications. That is exactly what we are touching in this today. And there are a number of reasons for a carrier to be more in the space of hosting, or to be more in the space of specific segments, to be more in the space of creating value and selling that value directly to the end users. Now, in this space, what is the role of Cisco? What Cisco is doing for the carrier edge? So Cisco's trying and wants to provide solutions to meet customer demand, operators demand in this case, and to provide tools that may help providers to meet their business outcomes. And so in Cisco, we are creating a different kind or set of solutions. And again, from this slide, you can see, if you look at the right side, we are going to create solutions with a top-down approach that are really use case driven, that we want to sell as monetizable applications. And this is value that service providers can sell directly to the end users. So there are providers, carriers are creating their own portfolio, their own catalog of service. Again, working with an ecosystem of partners, but they are the sellers of this value towards to the end users, potential end users. And I'm going to touch this vertical approach, this top-down approach with the next slide, since I think it's worth sharing a few details here. And then we are creating platforms for bottom-up approach. And when I look in this space, we do recognize that at this point in time, there's still a request to have a specialized platform for the telco functions. So for all the telco functions I mentioned before, so for managing the identity, the policy, the charging of specific users, this kind of telco functions in both the wired and the wireless space or the environment. So we see that the market is still asking to have a dedicated platform to support this telco function. So telco node, and they can live. If I look at the hierarchical nature of operator networks, they can stay at the center in the big NFV sites, so they can be distributed again as a telco edge nodes close to the users at the edge, leveraging a number of let's say technology options that today allows to move this telco function close to the users. And in between, in the middle, there is space for the platforms created to support services, to support applications, to support MEC applications and systems. So this is where value is created by third parties that may work close with operators, creating value for the end users. Now, as I promised, I want to spend just a few words to close my presentation, my speech, talking a bit about this third pillar. Since we truly believe operators may play a key role larger than what they have today. So going, let me say, beyond the pure connectivity. And this is really about and providing not only the infrastructure, but even value for end users. Let me say that even with the third and the second pillar, we are moving from a downpipe model, from a wide just one model to a more wallboard model, since the operators provide infrastructure that is the enabler for value created maybe by third parties. But if I look at the third pillar, we all see that operators have a good chance to get into the business and what is more, the digital transformation processes in a verticals environment, in the vertical. And this is a good challenge, is a challenge, but even a very big opportunity for operators. So we all know that verticals, when I say verticals, I mean any kind of enterprise in specific segments like transportation, automotive, industrial, manufacturing, healthcare. There is a long list. So they are all going through a huge transformation, a digital transformation, since they are all using technology in order to change their processes, to make efficiency or to create new business for verticals who are working in the market. So efficiency and new opportunities enabled by the digital transformation. So the operators can get into this process, can have a role, can have a place in this process, I would say, catch part of this digital transformation, and the edge is an enabler for the operators to try to be in that process, getting value, and again going beyond the connectivity. And 5G is for all of us a bridge between verticals and operators, and that is let me say the foundation, the infrastructure that create the bridge between verticals and network and operators, so that verticals can consume digital transformation from edge infrastructure or even cloud infrastructure enabled by the operators. So you see here on the slide what it could be a catalog of possible digital transformation services enabled by operators using the 5G as a bridge between verticals and the network, so that these use cases can be consumed as a service by the operator instead of investing it will be invested and incubated by the vertical itself, or in a collaborative way between the two. So here we see a very important opportunity. So, closing this is an opportunity connected with the chance for an operator to be the front man towards end users, and so creating not only the infrastructure, not only the enabler edge infrastructure, but creating value with a large set of partners, with an ecosystem, creating value for end users. But as we saw before, we truly believe that we see the opportunity for operators to not only creating a vertical, top-down, monetizable application for end users, but working to create infrastructure that may be used by third parties, like in the case of we are considering in these 2 days, hosting MEC applications and MEC platforms as well, creating the value and providing the value that third parties may enable, maybe with the applications that our developers are creating in these 2 days. This is my last slide, and I'm open to questions, if any. Otherwise, I will hand over to you, Dario.
Yeah, let's wait for questions. By the way, let me comment, Alessandro. Thanks for your presentation. Also, very impressive the kind of opportunities in many areas that can be related to edge computing, as you described here. It's very, very impressive. Thank you.
Thank you, Dario.
Okay. If there are no any other questions, of course, Alessandro, maybe you can stay here on stage, let's say virtual stage, in case of questions. And then since I see already the next speaker ready with the camera turned on, maybe we can also move to the next speaker, Maurizio, from Linux Foundation. And this will be, thanks again, Alessandro. This will be instead a more specific tutorial on the MEC location API. Thank you. Maybe in presentation mode, you put it, we see your notes. Okay, thank you so much. Better now. Thanks.
Okay, thanks. I didn't find the microphone. Okay, so thanks Dario for the presentation. Thanks everyone to be here. This is a tutorial. This will be a tutorial about location API. I'm part of Linux Foundation, that is the research center based in Turin, and we are busy in edge computing services. From recently, we thought to develop and to go through the MEC location API, since it's very important use cases in the edge computing platform. I see. So let me start an overview, the steps which we will go through. Briefly, I will recap what location API is from the ETSI standard perspective, because the location API that we are talking about are standardized by ETSI. Then we will talk about Linux Foundation solution, since there is no any kind of location API implementation till now. So we are between the first developers that we are working on the MEC location API. We are glad to provide this in this hackathon. Then I will explain and go deep into the solution. So we will talk about the simulator, why there is a simulator, and at the end, an example of how to implement a consumer application that consumes the location API. At the end, some future implementation. Okay, so location API is a location API service defined from ETSI standard, that is GS MEC 13. The version that I'm talking about is the version 2.1.1, because there is another previous version, and there are some differences between them. Location API, actually, the name says that provides location information about users, but who is a user? The user could be a smartphone connected to a radio node, or any kind of mobile device that's connected to a radio node. In the future, will provide their own position, their own location, and the radio node then collect this information, send to the MEC server in which the location API is placed. Location API will get this information and then will provide this information to the MEC application, so expose the information. But this is not the only the only feature of the location API, because it is able to handle this information, process this information, and serve in other kinds of states. Till now, the location API cannot be used because in the real time there is no telco operator that offers this kind of opportunity to get the location information. Okay, so the MEC location API are practically a RESTful API. So you can get this information as a simple web service, but there are some features, there are some procedures defined by EPSI. Here I point out two kinds of procedures that are the most important one. The first one is the lookup procedures. Lookup procedures are concerning the possibility to get information from the location API once for each location information request. So, for instance, there are several users connected to a radio node or to a different BTS, and if an application would like to get information of all users concerning or connected to a radio node, they can get this list of users, and so the lookup procedure is just an on-demand action that a MEC application can perform in order to get information and know what in a given zone or a given area which users are present. The most interesting procedure is the subscribe procedure. Why? Well, the subscribe procedure is similar to the publish to subscribe procedure. If you know about the approach, the subscribe procedure, MEC application can subscribe to a precise user equipment or mobile device or multiple device, and then can receive information from passively information from users which the information goes through the location API. So, for instance, if I want to track a given user, I subscribe to a user through the location API. A location API will be in charge to serve those information whenever it changes its own position and so on. The subscribe procedure, there are several kinds of subscribe procedures. There is the user tracking position, for instance, that I explained before. Then there could be an area subscribe procedures that is very interesting from the developer perspective, because it is able to, the area subscription is able to serve information whenever a mobile user goes through a given area that we decided to monitor. So it's very interesting from a MEC application perspective, because you can develop several kinds of services such as geofencing, other similar application for this kind of procedure. Then obviously the location API allows to delete the subscribe and handle with the following a given user and so on. But in real production environment, there is no, as I said, there is no possibility to use location API. So Linux Foundation thought to develop a simulator that destroy the wall for the MEC app developer and enables developer to develop and test to use the location API in order to be prepared for whenever the location API will be available in a real production environment. In order to do so, we developed a path simulator, and as you can see in the right side, there is a path simulator. This is our links. This is our simulator, location API simulator. There is a path simulator and the location API provided as a web server, and then there could be several kinds of MEC application that use the location API. In this way, we thought that implementing in a standard way the location API whenever will be available in real production environment, developers do not change anything. This is a quite useful way to go directly and scale up maybe a business model to go into the market for developer. Okay, now I'll show you how the simulator works. It is quite simple. This is useful for developer perspective. How can a developer use the location API in this event or in other events? Here we have a GPX file that is fed into the path simulator. It is able to read the GPX file and associate a given GPX file that is a file that collects all the GPS traces and associate this information to a vehicle, a smartphone, or in generic a station ID, and perform the simulation, post those information to the location API. The location API collects those information and then creates other environment information such as access point related to a given position, the zone related to a given position, and so on. So it starts to create other environment information useful for the location API service. Just to be clear, the GPX file in this version of our simulator that will be updated in several versions later on, but there is a given kind of GPX file. As you can see in the left side is an example. The sample show a GPX file that they could be different form. You can have a waypoint, you can have a track point, and so on. But the form that this simulator is able to read is this one, wherever a given trace is inside a track point, and the track is composed of track segment. And in turn, the track segments are composed of several track points. As you can see here, you can see a track point with a given latitude and longitude, elevation, timestamp, speed, number of satellites, and so on. But the only features that a GPX file must have are the location, the coordinates, and timestamp, at least, because the simulator will get this information and provide the location information to location API thanks to the timestamp and concerning the timestamp he is reading. In order to get this information, to get this kind of GPX file, on the right side I propose a possible solution to convert any kinds of GPS file to a GPX file, and also to convert GPX file in a given way where there is waypoints, route point, and so on, to the one I presented here. And you can see below there is the possibility to convert any kinds of routing point or waypoint to a track point in order to be able to use the location simulator, location API simulator. Okay, so now, as you know, the location API are placed in openness platform. And how can be used in the location API in openness platform? So the openness platform allows to onboard the application as a producer and consumer. And in this moment, the location API acts as a producer, so will serve other consumers make application consumer through its own information. Developers can, first of all, developers have to start a simulator for filling all the information to the location API. As you can see in the bottom right, there is the edge node, that is the openness edge node, and behind there should be a controller node where you write your file for developers for deploy your MEC application and so on. So on the top right, you see Path Simulator. As I said before, there is the two fields, station ID, a track. The Path Simulator can pick this information and start the simulation concerning the information you sent. Then there is a Make It as a Loop. Make It as a Loop allows you to simulate forever. So, for instance, there could be a GPX file that is simulate the movement of a vehicle in a circular way or a given path you'd like to iterate forever, or maybe whenever you want, and the Path Simulator allows to do that. Otherwise, if you want to launch once your simulation, you doesn't flag this option and start and stop the simulation whenever you want. So the first step is start the Path Simulator. Then the developer can start developing their own application. In the edge node, it's composed. The edge node there is the producer perspective, the consumer perspective. The producer perspective, as a location API is the producer. In this case, the location API is registered on the openness platform, and then it is able to serve all the information to MEC applications that are also registered in openness platform. So if an open application is not registered and authorized from openness platform, it is not able to connect to location API. I will show you in the next slide which label MEC application should have. Okay, now some hints about location API, how practically you can use it. Location API, as we showed before, you can use a lookup procedure that practically you can get information, you can perform an HTTP request as a get, and you get information of all simulated user equipments. Or if you want to get a specific one. Here, there is a command line example where you perform a request to location API, and you can see the domain name, the port, and then the name of the service of the MEC server, that is location, the version about the location API, and the kind of information you would like to receive. In this case, the MEC application will receive all the users that the location API is handling. So the other opportunity could be to receive information about a single user, and specifically in this way you will get detailed information with location information, with access point ID, with zone ID, and so on. So whenever you pick a single user, you will get detailed information instead of in respect to the previous. So whenever you get list, you will receive all the few information about users. And in this version of our application API, so Linux Foundation developed this location API with this is an alpha application. So there are a few features, but we are planning to develop and expand this feature. Till now, developers can exploit the periodic tracking subscription. What I mean is that that application can perform subscription to a device, a mobile device, and gets passively the information. But how? Practically, how can you get it? Okay, in order to do so, the MEC application must send a post request with a well-formed JSON message. The JSON message is shown in the bottom right and should have all this information. You should have the address at which you would like to register, and then the callback reference is a very important field because in the notify URL, as you can see, there is an example here, a domain example here, client.example.com. This should be your own IP address, or if you are using the DNS, your domain, and then the reference that is concerning your callback. In this way, Location API will know to who send the information. So if this field misses, Location API will send anything. Then there are other information, for instance, frequency, requested accuracy, that in this version, actually, they are not taken into account, but we are, as I said, we are planning to expand and extend this information. Then, if you want to delete the information, the subscription, sorry, you should send a delete request. The delete request takes into account a subscription ID that is received whenever the subscription is affected. So you have to maintain that subscription ID because it will serve to delete that subscription. Okay, for developing your own MEC application, there are two steps. It's very simple. First of all, you have to create your Docker image, and that should be able to connect and register on OpenSCAA. After the authentication, the Location API, the MEC application should check discover, thanks also to OpenSCAA, that discover all the services available in the MEC platform. Then check if the Location API is available. And here in the first image, where there is the list of services, you can find some information. I skipped some information, but you can see the most important information. If the Location API is a producer, the namespace that you will check for get information of that service, and then the info of the Location API, the DNS name and the port name. So when a consumer application is registered to OpenS platform, discover the service, whenever you receive the service and get information from Location API, it can you can get the DNS name to contact directly the Location API. So there is no mean between the Location API and MEC platform, but there is a direct connection between MEC application and Location API. And then the port where the Location API service is serving. This is the first step. You will be registered to Location API, to OpenS platform. Then, in the controller node, so since we have split controller node and edge node, controller node where you deploy your services or your application, edge node where your application will be actually placed. In the controller node, you should write a YAML file, and the YAML file you can see in the right side of the slide. This is a very simple YAML file. The YAML file will have a name, some labels if you want to add other label, and then other information. But notice that label has a location service active. This field when you deploy your MEC application is must be present because this allows the MEC application to get information, to get access to the Location API, to get access to the network of Location API. So if the location service doesn't exist in your YAML file, you should add it in order to be able to use the location API. Okay, since I'm in remote mode and VPN doesn't allow me to get a huge bandwidth, I prepared a video where I show you some steps of deploy your location API. In the left side of this command line, you will see the location API. Actually, in the right side, you will see a consumer application that I developed just for testing if the environment is working or not. I will comment it through it. I will comment through it, so there is no voice behind. I will do it in real time. Okay. In the right side, you see I show the consumer file that I showed before. It is practically the same. It has the label location service active. And then I start and create my MEC application. When I create a MEC application, obviously Kubernetes under the hood creates the pod and start the MEC application. Actually, here there is some latency since the edge computing is faster than me, and you will see before that I log here on the right side, you will see the information about the location API is serving the consumer application. Okay, here on the left side you see location API serving this lucky man that is able to get information from the location API. And then, okay, you see that I noticed that the location API will receive again from another consumer application a subscription. This is why Kubernetes approach, because whenever a pod shut down, it creates another pod automatically. So you will see twice your pod connected to location API if the pod exits before. Okay, now I go ahead and show you on the right side the consumer application, all the steps. Okay, start the information. Oops, sorry. Okay. You start the application, get the information from location API, as I showed before. Here there is the DNS name and the port, and create the URI to which the consumer application send information. Then get all the list of users, address, as you see. Oh, I'm wrong all the button. As you can see, there is a few information about the user and the user address, the access point, the zone ID, the resource at which a user can be you can get information, and other resources. Then the consumer application obtain its own IP address and perform a request. You can notice here notify URL. As you said before, notice URL allows you to location API send information to the MEC application. So the MEC application creates its own IP address or port, and then the subscription handler in this case, but could be any kind of handler or callback reference you can put here, and the location API will send directly in that position, in that callback as a post request. Okay, then if the consumer receives subscription response, and whenever the subscription response is got, the MEC application will receive post information. So it's connected to the user 10.0.0.2, it's actually arbitrary addresses, and then receive continuously information from the location API. Sorry. Okay, I skip this and then receive all the information whenever the location is changing. The location API serve the location application, the MEC application. Then this is a simple app. So is stay up for 10 seconds and then delete its own subscription. So delete its own subscription, delete all the resources, and then exit it. I show you whenever the application, how the application location API works here. Receive the information and request the request cancellation from the location from the consumer, and then remove all the information of that consumer. Okay. As you notice, the location API till now are very the location API has few features, but we would like to implement other features. And I would like to share with you which one feature I would like to implement, and this enable developers to enhance its own application. For instance, the distance subscription and lookup, it's a characteristic, a feature of location API that allows to know the distance between two users. Or multiple users, so or group of users. If you like to compare the distance between different users, you can get this information or on demand, so lookup procedure, or with a subscription. If you like to monitor a distance between different users, you can monitor this subscribing to them. Then the other one is, I already mentioned it, the area subscription. The MEC application can request through a JSON request. You can request a subscription, an area subscription, giving some coordinates, some information to a given area, and then the location API will be in charge to manages this information and send back location-related information to the MEC application. In addition, our simulator till now is very simple, but we would like to implement and enhance its own features, such as simulate different kind of user equipment and also their behavior, and then add the logic to the VTS. Since till now there is a single access point, there is a single zone node. It's not so easy to implement all the environment whenever the environment doesn't exist. So we have to digitalize all this information in order to get real location API, real context location API digitalized. Okay, I finished here. If there is some questions.
Thank you so much, Maurizio. This is a nice presentation. I am attracted also by your conclusion. If you can just go a little bit back to the. So you have some plan for future implementations. Do you think there can be also possible impact in future standardization work from, because you are also a member of the MEC, so this is based on MEC GS MEC 13, so maybe there is some impact you can foresee? Yeah,
I mean, these features actually belongs to the C standard. So what I mean here is that since the standard is quite huge, it contains quite a huge information about location API, all the features has link foundation. We want to be fully compliant with C standard. So as member, we like to share the location API as completed as possible.
Sure. As a first step, I think it would be also nice to give visibility to the group of this great implementation, because I think there is now in the code working group, so yesterday Michele Carignani from CCTI was presenting the latest advancements, and there is also an effort to showcase as well some nice implementations. I guess this is a very great example of diligent implementation of MEC compliant APIs, and also nice tools provided to a developer as a mean to encourage them to consume this API. So I will encourage you as well to present there. It would be great, I think.
I think so. Thanks.
Okay. Yeah, as usual, I ask you to stay here on stage, Maurizio, while we move to the next speaker. Of course, just to collect if there are any questions from the chat window. So, in case there are no questions, we may now move to Masaki Suzuki from KDDI, who is the next speaker, and he is a rapporteur of MEC 35 and kindly offered to present, connected from Japan, on MEC Federation and standards overview, so the work that he is leading in this perspective in the ERC-MEC. So thank you so much, Masaki, for being here. And yeah, it's up to you now to present. We cannot wait for that. Thank you so much.
Thank you. Can you hear me?
Yeah, sure. Perfect.
Yeah, and can you see my screen?
Exactly.
Yeah, thank you very much.
Ready to go. Thank you.
Yeah, thank you. So thank you for this opportunity, and I'm honored to give this presentation here in Droidcon MEC Hackathon. And especially, I'd like to thank Dario. So not only chairing this event, so you are really active and recognized across different organizations and different countries. So many of my company's activities cannot be conducted without his support. So I'm Masaki Suzuki from KDDI, Japan, and I'm a regular delegate for HCIC MEC and the rapporteur of MEC 35, that is about the inter-MEC system and inter-MEC system coordination. And today I'm talking about MEC Federation, including the overview of my company's activities relating to MEC Federation. And I will introduce the activities from KDDI's point of view. So let's get started. And here's the agenda. Before I start talking MEC Federation, I will introduce the general idea for the distributed MEC environment. That is the kind of background of MEC Federation. Then talk about inter-MEC host management that is captured in the white paper number 39. And that is a paired idea with MEC Federation. Then I step into MEC Federation, into system coordination with MEC Federation. After that, I have to introduce my company's vision. All of our activities are based on this vision. Finally, conclude this presentation. So here we start with the general idea for distributed MEC environment. So in general, we think we have two major types of deployment. First form is MEC for specific facilities such as factories, hospitals, or airports. We already have many good MEC deployments with this form. For example, MEC in factories enables automation of production processes, and MEC in hospitals supports remote medical treatment. And MEC in airports supports person identification for immigration. In common, MEC provides specific services for devices located in the specific areas or specific buildings. The other form is MEC for widely distributed users, such as for V2X services or for AR/VR gaming. In the use case of V2X services or AR/VR gaming, vehicles, smartphones, and AR/VR equipment are geographically distributed in the country or in the world. They associate with basically the closest MEC host according to their own location. Distributed form includes more challenging aspects. So now we focus on the case of MEC for widely distributed users. We especially focus on the certain levels of coordination between MEC hosts or MEC systems. First level is inter-MEC host management. When you think about the application relocation or MEC handover, if two MEC hosts belong to the same MEO, it's already supported by its MEC specifications. However, its deployment is a little complicated. So we published a white paper number 39 on enhanced DNS support for distributed MEC environment. And the second level is inter-MEC system, MEC file system coordination. That is the main scope of MEC 35. So different from the first level, if two MEC hosts belong to different MEO respectively, we need a coordination between MEC systems. If the other system is closed, we need a coordination between them accordingly. So here I briefly introduce inter-MEC host management. So as I said, application mobility inside the MEC system is already supported by MEC specifications. You can refer MEC 3 and MEC 21 and MEC 18 in detail. So MEC 3 specifies the reference architecture that includes the mobility aspects. MEC 18 is a study on end-to-end mobility aspects. And MEC 21 specifies application mobility service API. However, for me, it's a little complicated to deploy it into our own network. So we decided to provide a white paper to fill in the gap between specifications and deployment. The white paper also includes some extensions for implementation, adapting to additional operation policies. So here is the basic behavior of DNS support. The assumed network consists of one device, two MEC hosts, corresponding MEC platform and MEC platform manager, and corresponding MEC orchestrator and OSS. MEC platform associates with authoritative DNS server. According to the specifications, 3 key points are extracted. First, MEO supervises over system. Second, MEC platform provides connectivity with DNS server. And device associates with the desired DNS server, desired by MEC system. So basic information flow is depicted in the sequence chart. First of all, MEC system keeps the DNS rules up to date. That means MEO defines the rules, and MEC platform reflects the route to the DNS server when device tries to connect to the application. The device asks DNS server to resolve FQDN to IP address. If the recursive server does not have a cache for the FQDN, it forwards the query to authoritative DNS server. Then authoritative server responds with IP address and the recursive server forwards the response to the device. Device is finally able to connect to the application on MEC host A. Then, when the DNS rule has changed, the rule is defined by MEO and reflected by MEC platform. After the DNS cache is expired, the device asks DNS server to resolve the FQDN to IP address again. DNS returns the updated IP address to the device. Now the device establishes a connection to the application on MEC host B. So as you may notice, one important thing is how to configure the appropriate expiration duration for DNS cache. It's important. So regarding the extensions for implementation, we extracted 3 requirements from the use case. First one is that operators want to dynamically choose the serving MAC host based on operation policies other than location, such as according to the available resources. According to geolocation, the device may connect to MAC host A, but if little resources are available on MAC host A, device may be better to connect to MAC host B. Second one is that different devices may need to connect to different MAC hosts, for example, due to their own location or available resources or other reasons. Two different devices may associate with the same DNS server, but the response to their queries should be different. The last one is how MAC system may need to dynamically update the serving MAC host as device moves. So as appeared in the previous slide, device updates the serving MAC host basically after the DNS cache is expired. Usually, MAC applications are latency critical so that device should flexibly update serving MAC host should be resolved for the better experience. In order to resolve the gap between devices, we consider the task of forwarding from devices to MAC system. So two roles of MAC system are expected. One is to offload the computing task to MAC system. The other is to provide a better latency to the device, especially after coupling users. Now the problem is how those players fight against each other or cooperate together in case where those two devices are associated to different MNOs network. In this context, we think both MEC to MEC coordination and MEC to cloud coordination efficiently work for this use case. So now, Ilya thinks several variations of combination are possible for MEC and external system coordination. And we listed up 5 patterns. First one is MEC system in MNO1 and MEC system in MNO2. The second one is MEC system in MNO1 and the edge cloud in MNO1 network. Here, edge cloud defines as a service shared infrastructure among MNO and the cloud system. It aims to dump first and third services to application providers. The third one is MEC system in MNO1 network and the edge cloud in MNO2 network. It could be a subcase of the first option. And the fourth one is the MEC system in MNO1 network and the central cloud system. Here, central cloud system means, for instance, AWS or GCP or Azure, such kind of hyperscale cloud system. And the last one is MEC system in MNO1 network and the on-premise cloud system in application provider's environment. And in our opinion, the idea of MEC federation is applicable for these cases highlighted with red arrows. Some of the edge cloud are also covered by the scope of federated MEC. However, coordination with the central cloud and private cloud that are located outside the MNO network, we need further study on this point. So MEC federation is enabled based on the idea of east and westbound interface defined by GSMA OPG. As long as I know, they have already published 3 white papers on this topic. First one is the operative platform concept phase 1. According to this, operators will collaborate to offer a unified operative platform in phase 1. The operative platform will federate multiple operators' edge computing infrastructure to give application providers access to a global edge cloud to run innovative, distributed, and low latency services through a set of common APIs. So, MEC 35 study is respecting the idea of east and westbound interface. Second and third ones, GSMA operative platform Telecom Edge proposal white paper. This is a white paper, but it looks almost like the high-level specifications. And take H4, its service description and commercial principles white paper. Those white paper are really recent documents, so MEC 35 is trying to extract the applicability of federated MEC and to provide further alignment. So based on the use cases and the idea of federated MEC, we extracted what should be enabled by MEC federation. So Kira recognized several functions should be enabled and grouped them into two categories, as an application level functions, synchronization and transfer and deletion, and maybe other functions should be enabled. And what is required to be supported by MEC systems? MEC system discovery, MEC platform discovery, the also MEC application discovery. And the MEC service consumption, that also means the MEC up-to-up communication. Maybe other functions may also be required. So in order to enable those functionalities, structuring the hierarchical signaling is our first step. Here is the simplified architecture that consists of functions structuring the hierarchical signaling. In the figure, the higher part is the system level, and the lower part is the platform level. So regarding the correspondence with GSMA OP, northbound interface is above the OSS. And the east and westbound interface is linking between system level of the two MEC systems. So we introduce Federation Manager that will be explained in the next slide. Signaling among specific functional entities of the involved MEC system for four objectives. First, for system to establish a security trust by authorizing each other. For an application provider or customer to deploy its application across multiple MEC systems using a single MNO relationship and integrations. For a MEC application in need of consuming a MEC platform service. For a MEC application in need of communicating with each other MEC applications. So in order to realize the structured signaling, we introduce new functions. First option is Federation Manager, and the second option is the combination of Federation Manager and Federation Broker. Federation Manager is located in the MEC system level and connected to MEO. Associating new two reference points are also introduced. MSM-FED connects MEO and the Federation Manager, and the MSF-FED connects two Federation Managers. Federation Manager is responsible for the list of functionalities, authorization, security, application lifecycle management, resources of platform, publishing, and discovery. Exposure of the catalog of MEC systems, and the publishing and discovery during all assurance functionalities. Regarding the Federation Broker, we consider primarily a Federation Manager entity for each MEC system with P2P agreements between them. As an alternative plan, a Federation Broker could be considered to avoid the complexity to reach a high number of Federation agreements. In this context, an additional reference point, MFB-FED, is introduced that connects Federation Manager and the Federation Broker. Federation Broker is a kind of hub function among a high number of federated MEC systems. In order to enable service consumption or MEC up-to-up communication, MEC system needs to identify which MEC systems are the member of an already established MEC federation, or which MEC systems are available to form a new MEC federation. So step one, a service communication query is issued by a MEC application that is instantiated at MEC system number one. Step two, MEC number one contacts the Federation Manager to obtain the necessary information of other MEC systems via Federation Manager. that each MEO shares its own information with Federation Manager in advance. Step 3, MEO number 1 finds out or selects the desired MEC system. After the target MEC system is discovered, step into MEC platform discovery. Here we consider two options. One is direct communication between MEOs, the other coordination via Federation Managers. In order to find the appropriate MEC platform, the decision will be made based on the performance or location or other metrics. The metric may include the communication latency between source and target MEC platforms. Therefore, MEC has to exchange those information in addition to MEC platform identifier. Here we have two options to exchange the information. One is the MEO direct interface, and the other is via Federation Managers. So as for the direct communication between two MEOs, we consider the security policies and agreement between different MEOs. And on target, the information exchange can be conducted via Federation Managers. And now we can finally enable MEC service consumption and the MEC up-to-up communication. I would like to note that this is the simplest option for realizing service consumption. The service consumption and the up-to-up communication is conducted via direct interface between two different MEC platforms across different MNOs. MEC application on one MEC platform consumes a MEC service on different MEC platform across different domains. So even in this case, coordination between these two MEC systems may be conducted via Federation Managers. That's from my understanding. And I'd like to also note that the network between MEC platforms are out of scope of this study so far. I mean, not all MEC platforms in MNO1 may be able to directly communicate with all MEC platforms in MNO2, even in the case of direct interface. In this case, the limited combination of MEC platforms across MNOs are able to communicate with each other. So some MEC platforms have to support the other MEC platforms to communicate with external MEC platforms. So as a summary of collaboration and alignment with other organizations. As for 5G use case and requirement are extracted from 5G activities, especially regarded as multi-MNO cases. As for GSMA, technical requirement and outline of the potential solutions are extracted from GSMA OPG activities. Activities in those two organizations is linking in this study, of course. The idea of federated MEC system is one of the key solutions for the requirement from 5G. And from its side, the technical aspects will be provided. Currently, study and analysis are ongoing. For instance, hierarchical signaling framework for MEC federations, and the new elements for federation considering security concerns. And some part includes MEC unique options different from those other organizations. And the normative work will follow this informative work. New functions, new reference points, and the corresponding APIs, including data models, will be further specified. And this part should be presentation only. So could you kindly pause recording, Miko, the video? Okay, thank you very much. So as a concluding remarks, the scope is wide and deep, so but we make it forward step by step. So respecting 5G AA and GSMA OPG activities, our goal is providing new values to the industry and better adoption in the industry. So this concludes my presentation. So thank you very much, and I have to apologize the inconvenience. Thank you.
Oh, thanks to you. Thanks so much, Masaki, for your availability and your kind work. You are doing great work. You are doing here as a KDDI and rapporteur. It was, I think, very useful, very technical, very detailed, but at the same time, very timely. This is a very, very important work, in my opinion. Thanks so much again for being here.
Can I ask you, can I put in a quick question here, if you don't mind, Dario?
Oh, fantastic.
Masaki? Yeah. So I'm really interested in this kind of stuff, right? Also from my perspective from my org, of course, right? It makes sense for these MEC layers to communicate to each other. So I'm definitely going to take a deeper look at your presentation. You're talking about other organizations you're liaising with, right? 5GAA. Are you also running this with AECC, for instance? I mean, that is much more your side of the world, right? Really dominated by some of the Japanese players. Are you liaising with them as well?
So, can you hear me?
Yes.
So let me respond. So I cannot catch the organization's name of the organization.
Oh, AECC, the Automotive Edge, whatever. It also deals with MEC
Computing Consortium.
Thank you, Leo. Thank you. I knew you would jump in. So because this is yet another organization heavily focusing on MEC in the automotive industry, and also trying to deal with this kind of stuff, trying to reinvent the wheel, but looking at the stuff that's already been done in 3GPP. So I'm simply inquiring if you're liaising with them as well, because all of these organizations really have to come together and come up with joint architectures that look the same.
Yeah, thank you very much. So yeah, AECC, actually my colleague is also joining the AECC. And so actually I think we aligned, but I think the scope of AECC is more application side so far.
But what also dealing with this kind of stuff, right? Multi-MNO MEC, right? Really, yeah. But it's fine if you're engaged there as well. I think this is really the most elaborate explanation I've seen so far on how we can make this work. Yeah. So thank you for that.
Yeah. Thank you much. Yeah. So my answer is not so far, but in future we can collaborate together. Yeah. Thank you very much.
Cool.
Fantastic. Other questions, comments? Otherwise, I would say we deserved our lunch break.
Yeah.
And thanks so much also for connecting. Maybe it's a little bit later for you, Masaki, but very appreciated the level of details. Okay. So if there are no any other questions, and so thank you, Masaki, thank you everybody, and thanks Guido for the question, and everybody for the attention here. I think according to the agenda, let's reconvene at 2 p.m. after the lunch break, the latest round of keynote speakers and the final panel discussion. And welcome to the afternoon session of this MEC Hackathon. So, yes, next speaker according to the agenda is Nicola Faronato from the city of Turin, and the keynote is on Edge Cloud and Innovation on Automotive, the Smart Road Project in Torino City Lab. The speaker will present the Smart Road Project, a consortium of partners from car makers, network operators, universities, and the city of Turin, with the aim of develop, implement, and test advanced solutions in the urban environment of Turin. And welcome, Nicola. I see you online. And
hi, Dario.
Maybe you can get, hello. You can get the presenter role, and the floor is yours. You can present your slides. Thanks again.
Perfect. Thank you very much first to all the MEC Hackathon team for inviting me. It's my, I guess, second time second involvement in this great event, and I really want to bring you the remark from the city of Turin in terms of appreciation of the great job that you are doing. Great team behind, great companies, and great support. Well, the good thing is that, as you can see from my first slide, we as a city, we want to be and to continue reaffirming that there is a clear and proactive role of the city towards innovation and towards the exploitation of new emerging technologies. The fact that Turin Payoff is connected with the city partner of innovation is very important, because that means the city has taken a direction of becoming more and more equipped with talent, with skills, with infrastructure. And let's just remind us that, of course, emerging technologies such as edge computing and few others that we will comment in this section are very important, very crucial infrastructures to allow the city to become smarter, to allow the city to attract new talents, and to allow the city to be a partner for innovation. So my speech today is starting from a big picture that I would like to provide you. And the big picture actually has to do with the nature of smart city in Turin. So as you can see from my slide, actually, this is what we normally use for describing the concept and the idea that we have of smart city. A smart city for us is the combination of a number of smart towns or smart districts within the perimeter of the city. So it's very important because, of course, the concept of smart city is probably 30 years old, so it's quite dated with the pace of the current innovation curves and the current economy. And it's very important that we continue making this concept and accompanying this concept in a transition of a more modern view of smart city. The modern view of smart city that we are trying to build is a view connected with a city willing and able to be a house for emerging technologies. So a house for emerging technologies means that you are, first of all, open to welcome them. So there is an attitude, and you are able to create around yourself an ecosystem able to support you as a city to to go through this journey, which is quite complex. And as you can know, emerging technologies typically bring new challenges to the table. They bring new exponential challenges. So the complexity is rising, and the city, by design, needs industrial partners, needs research partners to continue transforming and evolving from, for example, a post-industrial status to a smart city status or a future city status. That's why Turin, after with of course quite a lot of industrial and post-industrial DNA, and also quite a lot of innovation DNA, is leading the transition of the city and all its stakeholders towards a smarter city. I like to flag this incremental concept of smart city because it's of course not a stock, but it's rather a flow, since the city needs to continue every day to embrace new emerging technologies and to empower its infrastructure and to open up to innovators from all over the globe. So the idea that we have of a smart city is, first of all, an idea based on an agenda. So we have an innovation agenda, and the innovation agenda, of course, has to do with a number of verticals that the city is willing to build and to develop. When we speak about verticals, one vertical at the core of the city of Turin is certainly mobility. So the way we look at mobility is a multidimensional way of looking at it. And by multidimensional mobility and even circular mobility, so two different attributes to this vision, we intend the fact that, of course, the city starts from a very important background in automotive. The city is quite well equipped with a number of companies from the automotive sector. And the city is also aware that there is a very important transition with new mobility paradigm that are not only looking at what's happening at road mobility level. So for us, smart mobility doesn't equal smart roads. It's a concept that can go beyond and can go to a set of dimensions with mobility. For example, road mobility plus air mobility plus water mobility plus space mobility. So 4 dimensions, 4 trajectories that combined create a more holistic concept of mobility that the city is looking to embrace. So there are a number of challenges with each of these trajectories. And there is also quite an extended contamination and cross-fertilization in between these 4 smart mobility trajectories and the number of other areas that you can see in this slide, such as AI, artificial intelligence, quite pervasive as emerging technology when we speak about mobility, but when we speak about a smart city per se. There is, of course, manufacturing and the whole concept of Industry 4.0. There is, of course, science behind. There is, of course, healthcare behind. So the agenda that you see pictured in this slide within the perimeter of the city is a very important agenda, innovation agenda, that the municipality, so the public administration side of the local government, is willing to support, is open to accelerate, and in principle is looking to enable, so to be a proactive partner of these new paradigms to happen. So this is a very good news because we have seen from a number of rankings, we have seen from a number of facts that Turin is a very forward-looking city in specific areas such as mobility. So mobility is a very important area of development, of innovation, of agenda, both political and socio-economical, but it's also connected with a very important infrastructure that we need to consider when we wanted to speak about mobility. So before going to the more detail of the infrastructure, I would like to add a comment on the approach that the city is bringing to smart city policy, and is, of course, an approach that is quite connected with the technology level of maturity. So we are well aware that the technology readiness of an innovation needs to go through a number of steps. The 3 steps that we are mainly concentrating here are experimentations. So Turin is a city which has positioned itself as a city lab. So a city looking at experimentation and open participation to its ecosystem as the first key step for accelerating technologies and emerging technologies to happen and to add value at the city level. Of course, going through an open innovation environment in which public and private partners can collaborate you can accelerate some maturity levels of the whole TRL curve, but at the same time, you need to be very accurate when you pick up the right partners and when you choose the right partners. So there is a partner selection layer, which is very important. And the city is not leaving it at the free, let's say, market per se, but it's rather trying to look at how the city, so the local municipality, can boost or can have a voice in this selection, and it's very important. The third stage of the role of the city, and it's a public-private partnership, is connected with the scale-up in a way. So how you bring an experimentation to a validation, and the next stage to a possibly scale-up, industrialization, and growth of the whole ecosystem. This can happen internally or externally. This can happen with local partners or with international partners, and that's quite an important fact. So key part of the approach of the city is the high-level matrix that you see now in my slide. So if we start from the concept of green, willing to be home for emerging technologies, it means that the city needs to build internal skills, internal knowledge, but also external knowledge coming from its ecosystem to be able to add the value, connect the right dots, in particular when we speak about demand and offer of innovation. And you can see that edge computing is part of the key technologies emerging, is part of the key priorities in terms of technological outlook that our agenda has. And this in particular complementary with a number of tangible infrastructural assets that the city is putting together to pick up the emerging technology and deploy this technology in order to maximize its impact and its value. So again, we are at a high level here of reasoning, but it's very important to consider that city platforms like Torino City Lab, some of you may have already known about this, are intended to be catalyzers, catalyzers layers, supporting the city in the transition from where the city is today to where the city wants to be tomorrow. So a city able to pick up emerging technologies and rightly deploy them in its urban innovation agenda in order to have the maximum impact. Along with technologies, it's very important to connect the technology layer, either software or hardware, with the human capital layer and the research, especially applied research layer. This is, of course, part tangible, part intangible, but it's a very important block of this house of emerging technologies, because without the capacity of attracting the proper human capital and attracting research, again, either done by local partners, so research entities already in the territory, and also done by external partners, so research entities located outside of the city, but interacting with the city with some pan-European projects, some funded research projects, and so on. That is very important for us. So the first part of my speech has been concentrated in providing you a little bit of background about what's the approach of the city towards innovation, ecosystem, public-private collaboration, and emerging technologies. We have to consider, in fact, that speaking about emerging technologies means the content we are mentioning today is most probably different than the content we will mention in 6 months' time. So the TRL of the technology, even if we have technology families, is of course a fast growing curve and is bringing quite a lot of change for the city and for its stakeholders. Again, and I'm going back to what I was mentioning before, in our agenda, mobility is very important. And probably the milestone of this mobility is represented by the Torino Smart Road. So Torino Smart Road is, again, a public-private initiative, which is aiming to do at least two things. First thing is to build an ecosystem which you can support the city in the transition from the analogical vehicle to the connected and autonomous vehicle. Second step is equip a testing area, so an urban circuit, as the one that you are seeing in the slide, to be a testing pad for innovators.
Oh, it seems we lost Nicola.
Yeah, I cannot hear Nicola anymore. Can you hear me, Dario?
Yes, we can hear you, Mir.
Okay.
Yes.
Okay. Let me send him a message. Maybe there is a bandwidth problem from his side, I see.
Nicola, can you hear us? Let's wait just 1 minute. I sent a WhatsApp message to Nicola just to understand.
Check from.
Oh, Nicola, we lost you in the last minute.
Can you hear me?
Now, really well, yeah.
Okay, I'm sorry, but probably we have got some tech, so some connection downturn here. So I'll try to go back from where I left. Okay, so you should see my screen again.
Yeah, absolutely.
So I just make a step back.
Yeah, actually, we lost you in the previous one.
Yeah,
this one, exactly.
So,
the circuit.
I'm just going to stay for a second here. Okay, so the concept of the Torino Smart Road is very important for the city, since it's of course one of the first cases in Italy, at least, for a pre-approved circuit in which the city can be an enabler for innovators in the Smart Road initiative to actually come here, test both infrastructure, test and deploy both infrastructure and connected and autonomous vehicles, and be part of an ecosystem, of a local ecosystem, which is again a very important fact. So smart cities are creating local ecosystems to be able to go through the journey of these emerging challenges, such as the Smart Road Challenge and the Smart Mobility Challenge. So what we have started to create in Turin is an infrastructure, which, by the way, we really hope that will be able to get some new investments very soon, since we have applied for new funding here. So we are expecting, finger crossed, some possible interesting funding coming at national and international level. with the aim of completing the infrastructure, updating the infrastructure, and keeping the infrastructure up to date, state of the art, and unlocking new opportunities when we speak about experimentation, innovation within a smart road. So 3 very important facts connected with smart roads are the fact that about 40 players, some car makers and some service providers and technology providers mainly, have decided to adhere to the Turin Smart Road projects and are still involved in a number of R&D projects, which we are trying to mature to create critical mass for research and development and implementation, starting from Turin, and of course benefiting from the position of the city towards smart mobility and smart road, and benefiting from potential assets of the city through, for example, the smart road circuit, through, for example, some, again, funding schemes and international collaborations. So fact number 1 is that smart road means not just a physical or technological infrastructure, which is step 0, but means an ecosystem of partners willing to raise the bar when we speak about smart road initiative. Second very important fact is that Turin has been the first city in the world to join 5GAA, a very important association willing to advance the state of the art of connected and autonomous driving, also in terms of standards. Last year, 2019, we have got the pleasure to host 5GAA annual conference here in Turin with quite a few interesting use cases. Again, there is some video material here, and it's quite interesting, the perspective and the continuation of some discussions that are going through with 5GAA as a network. Third very important fact is that smart road means also scouting talents around the world and trying to attract teams here in Turin, thanks to a great enabler, which in this case is Techstars, and our main engagement partner, which is Intesa Innovation Center. So Techstars, one of the top 3 acceleration programs and early stage investors globally, has decided to land in Turin last year and already have launched the first program. We are through the selection of the second program. So this is very important because, again, it's a bottom-up approach to creating critical mass in the city when we speak about smart road. We have, and we are continuously looking at testing experimentation opportunities. At the beginning of this year, this special year, as we all know, due mainly to our programs completely changed due to the COVID-19 pandemic. We have started the year with a very interesting project, which has been a shuttle service, autonomous shuttle service, made in Silicon Valley, but and actually brought in Turin, thanks to Turin winning actually as one of the 2 European cities the challenge of Local Motors, this innovator in the smart mobility space, and which has allowed us to actually deploy a autonomous shuttle service project within a UN campus that we have here in Turin. It has been an interesting project, of course, much affected due to this exogenous factor of COVID in terms of agenda, but we are really looking at restart and reboot just after the pandemic. Just a couple of remarks before opening to Q&A regarding another couple of interesting angles. I was initially speaking about multidimensional smart mobility approach. It means, in my opinion, and I'm really open to discuss about that, that we can imagine that a piece of the infrastructure can be horizontal. So a piece of the infrastructure and edge computing can be one of these pieces, can be a common trait among the different smart mobility experimentations and directions. So road, air, water, and space. We are, as a city, very active in UAM, urban air mobility. We are bringing a lot of experimentations which requires AI, cloud, edge, 5G, and all this bunch of infrastructural technologies to be able to run autonomous driving, autonomous flying, space flying even. And we are continuously looking at making more robust the concept of the city as an innovative city with a circular smart mobility paradigm. So we would like really that there a contamination among the four trajectories of mobility could create competitive advantage for the city to attract experimentation, to attract innovation in terms of smart mobility. So smart mobility is really a key driver of our innovation strategy. In fact, thanks to this key driver, we have been most recently adding to our portfolio of technology and innovation partners a number of premium international global brands. We are willing to continue to do that. And thanks to events like the MEC Hackathon, we are willing to continue sharing and becoming a partner of innovation. Thank you very much. I'm really available to support this program also through Q&A, and I hope that you all have received my contribution well in terms of everything.
Thank you. Thank you so much, Nicola. Thanks for your presentation. Let me ask if there are any questions. I cannot hear you anymore.
Yeah, Dario, I'm of course available to, even in case that some questions may arise in the next few days, as well as you want to share my direct email and, I can add contribution, take into consideration that, of course, I can be the connection in between you guys, so participating to the MEC Hackathon with Torino City Lab and the city.
Yeah, thank you so much. That's a good sign of the Torino administration. And so, yes, I have asked you, let's say, just to stay a couple of minutes in case someone will write some question in the chat window. And by the way, I remind everybody, so there will be a final panel discussion at 5 p.m. and Nicola will be a panelist as well there. So, and let's move to the next one, which is Andrea Laganà from Team Telecom Italia, Edge Computing Implementation, the Telco Viewpoint. So I see now also Andrea with the video connected. Thank you, Andrea. Now the floor is yours. Thank you.
Here we are. Thanks, Dario, for giving me the floor. Good afternoon, everybody. I'm Andrea Laganà, as you said. Thanks for your introduction. I'm from Team. I work in the Technology Innovation Department in Team, where I'm in charge of 5G innovation trials. Well, all of you know that this event should have been held in Turin, of course, physically. And Turin is the city where the Historical Research Center of Telecom Italia was based, formerly known as XELT, and then TLAM. And so for the last 50 years or so, Turin has been the classical target for trial and test of new technologies for Telecom Italia. And this is still happening now because anyway, in Turin are based most of the people that in Telecom Italia deal with innovation. And in fact, this has happened also for the edge computing technology, which is a sector where Telecom Italia has worked very much in the last couple of years. Probably it's a topic that where more effort has been concentrated in innovation in Telecom Italia. And in the last few months, we've had some tests in Turin on edge technology as well. So this afternoon, I'll try to give you an overview of edge computing technologies from the telco operator perspective, based also on the experience that we've had in Turin in the last month. First of all, I'd like to start with a definition, let me say, in order to be sure that all of us are on the same page, and I'd like to build a common ground of understanding to be sure that everyone is clear what we in Telecom Italia refer to when we talk about edge computing. So edge computing is a form of cloud computing implemented moving data and processing power closer to the source of the data. So closer to the source of the data, in other words, in the edge of the network, that is where customers produce and consume their data. So this is a very simple definition that reflects our view of the issues. And the first observation, very relevant, is that edge computing and centralized cloud computing are not mutually exclusive, are not alternatives, but rather they absolutely are complementary. So we completely agree with the concept shown this morning by Cisco on the continuum computing, because as a matter of fact, it's a matter of adopting a strategy of distributing computing power through the topology of the network. And interesting enough, a relevant solution for a telco operator is also the case where the edge computing nodes are located at the customer premises. So the customer location is one of the possible options to place the edge computing nodes for a telco operator. So in other words, adopting an edge computing approach means for us distributing hardware and software resources in a large number of locations on the field, in close proximity to the customer, and also in this location provide to app developers, to app providers, in an open and secure way, the capabilities to exploit the big potential in terms of network capabilities that the application may have by simply the fact that they are running in that portion of our network. Let's see a bit more in detail what I'm talking about in terms of the network capabilities. Some very simple example. First of all, well, it's the most classical network capabilities we are talking about in these 2 days, which is latency. Well, by definition, if the data, the computing node, is placed very close to the source of the generation of the data, of course, the flow of data will cross a small segment of the network. There will be a very short path run across by the data, and all these help, of course, to keep the latency low, having great latency performances, which is, as you know, may be crucial for some type of applications, such as real-time applications. Second point is what we used to call internally as local processing. Well, if you have the computing node close to the customer, close to the data, well, we limit the data transfer through the network. We have the elaboration of the data locally, close the customers, close to the origin of the data. And that means that we can avoid to impose to the rest of the network strong requirements in terms of performances. There is one very simple example, very often referred to better show this case, which is the sport events or entertainment events. If you think of 1,000 people being in sport facilities, watching a sport match or watching a music event or whatever, you can think that they can be pushing in the network huge amounts of data through uploading video or content, or the other way around. They can be downloading their videos, their content from applications related to the events they are participating. Well, for sure, if we have the elaboration of the data directly at the facility, the sport facility, directly in the area where the event is based, of course, we avoid a strong impact to the rest of the network, and we avoid to making the event depending on the performances of the rest of the world. The third point is very close to this in terms of application and what we call limited autonomy. Well, of course, if you have the elaboration of the data close to the origin, we get independent of the behavior of the rest of the network. It's a sort of resiliency, of course, for the application, for the services, which can be really important for some types, again, of use cases and applications. So no matter what's happening in the centralized data centers, because we are able to run the service without any impact. Last but not least, of course, it's privacy and security. We all know there may be applications, use cases, scenarios where privacy and security requirements are very stringent. Well, if you have and this is a case also specific for the option I mentioned before about having the edge computing node directly at customer premises. I was saying if we have this condition, of course, we avoid that sensible data of the customer applications go through the network, through the public domain, while instead it can stick in the network of the customers without having any issue about privacy and security. So very quickly, this is a quick overview of the scenario, of the capabilities that the telco operator can offer to applications if applications are positioned at the edge of the network, which is really the big value that we can offer in terms of performances. Of course, this doesn't come for free. We very well know that there are impacts in building an application and making the application able to be deployed in a different part of the network and not only in the centralized cloud computing nodes. But of course, there are impacts also for the network operator, and I'll try to show you some of these impacts. Let's start from a very simple picture of what is a distribution, typical distribution of network functions when edge computing is not introduced in the network. You see on the left-hand side of the picture a number of network functions that usually are deployed in a centralized way. We're talking about user plane functions. We're talking about applications, of course. We're talking about databases and more all the functionalities related to the data layer and so on. In a country like Italy, the dimensions, I mean, like Italy, the telco operators managed to implement these functions in an optimal way with more or less 10 sites where centralized functions network functions are deployed in a centralized way. That means that there are more or less 10 points of presence, 10 data centers where these functions are deployed. If you think, let's refer, for instance, to the mobile access architecture as a reference. If you think of the centralized unit of the mobile access network, you see that immediately the order of magnitude increase, and we talk about hundreds of sites where these functionalities need to be deployed. And if we think at the most peripheral central offices, those that host the distributed unit of the mobile access network, immediately we are raising and we get to thousands of sites hosting this kind of network functions. So this is without edge computing. Once we introduce edge computing, of course, we have the impact I was introducing before. First of all, we have some of the functionalities that were centralized in the previous scenario that now need, of course, to be deployed in a distributed way. We're talking about the user plane functions and, of course, of the applications especially. And this is the impact because, of course, 10 or something like that of centralized computing nodes, but we're talking of the deployment of thousands of centralized computing nodes. So this is a strong impact, and that means that, of course, these distributed nodes won't be absolutely the same as the centralized nodes. They will be built in a different way. They will have different size, different availability of resources, of course, different scaling profiles, and so on. Let's see this concept in the next chart as well, where there are here two main concepts I'd like to highlight. So on one side, for sure, we have different types of computing nodes deployed depending on the place of the network where they are deployed. And so they will have a different support for applications, of course. But on the other side, we absolutely need to take into account that these edge computing nodes must be conceived and must be built absolutely as a cloud native environment, exactly as the traditional centralized cloud computing nodes. So the only difference must be that they are deployed in a distributed way, but they must have these characteristics in order that the application developers, the application providers will be able to exploit them to deploy their application in a seamless way. So no matter what is the location of the computing node, no matter what is the size, how it is built, but from the point of view of the app, from the point of view of the app developer and the app provider, we must be sure that they can use it in the most easy way and in the most seamless way the application can flow from one side to the other in this topology that we are going to do. This is translated in a number of requirements, in a number of cares that telco operator need to take towards the application world. Let's say that first of all, of course, the care is towards the developer of the applications, because for sure we must ensure that whatever is the location of the computing node, the developers need to be able to use the same set of development tools that they use for centralized cloud computing. So no impact on the way that the developers need on the way that the developers have to build their application, to develop their application. The second point, again, is on the capabilities network capabilities that the telco operator offer at the edge. Of course, we must be sure to provide the widest set of open APIs that allow the app developers, the app providers, the app themselves to exploit the network capabilities that we're going to offer. That's the real value. That's what we want to exploit. That's what we want that the app manages to exploit in order to make a success. It's really the thing that we need to push. So API exposure is fundamental in the flexibility that we want to build in the topology of the computing nodes. Third, last but not least, and not the easiest point, is on the side of the deployment of the application. Of course, as I said, these edge computing nodes will be different from the centralized computing nodes. There will be different instances of edge computing nodes of different types, depending on the context, on the type of central office, on the place in our topology where they are deployed. But we need to be sure that all the applications are not impacted by these differences in terms of computing power, in terms of hardware resources, and so on. So we need absolutely to use and to take care about the technologies that can make this happen, which are containerization, Kubernetes, possible solutions, and so on. So this is not a simple thing to implement, but it's really crucial in order to be sure that what we are going to build in our topology is really effective and can be adopted by the applications. Next step, I would like to show you a possible approach, a possible architecture in order to implement all the steps that I very quickly described in the previous slide. So let's see this possible approach, which is based in the implementation of an edge computing node, which is based on the separation of the edge computing node in two basic components. The first component being the telco edge component, and the second component being the service edge component. Well, the telco edge component is definitely strictly related to the telco functionality. It's definitely managed by the operator, and it's absolutely devoted to implement the network capabilities towards the app. That means that it implements basically two functionalities. The first one is the traffic breakout, what is called also local breakout traffic, which is the capability to divert the traffic coming from the access network towards the applications that are running on the edge platform, instead of leaving the traffic flows towards the centralized cloud, towards the core of the network, towards the rest of the network. The second functionality is, of course, the exposure of the APIs that allow the services and the applications to exploit the network capability available at the edge of the network. So first component totally dedicated to the telco functionalities, and as you can imagine, the second component will be dedicated to the application, the service edge component. In fact, it's the component that include all the app environment. It's the component where all the operations related to the entire application lifecycle are performed. It's where all the APIs towards the developers ecosystem, towards the application ecosystems are performed, are supported. So this quite clear separation between the two components. If you adopt such an architecture, well, you'll have a great advantage. That is that the two components may be very loosely coupled. There may be an independence on the two components. Thinking of the location of the two components, we have that for sure, as you can imagine, the telco edge component is, as a matter of fact, a real node of the network of the telco operator. It must be completely integrated in the network of the operator. And in fact, it must be placed in a central office, in a peripheral central office of the telco operator. On the other side, we have a bit more flexibility for the service edge component because, of course, it can be placed, co-located with the telco edge component, that is in the same central office where the telco edge component is placed. But we have also a couple of alternative options. First of all, we already mentioned the possibility to place it at the customer premises. If, for instance, the customer has its own application managed on its own the services and the application. But also the service edge component can be placed in an external data center, in a third-party data center. Of course, this data center must be quite close to the central office or to the customer premises. I mean, it must be in the area, must be a local data center with respect to the telco edge component. Of course, the performances in the three cases for the location of the service edge component may be a bit different. In terms of latency, for instance, of course, you will have the best performances in the case that the service edge component is co-located with the telco edge component. But in most cases, in what is normally the metro backbone of a telco operator, which is practically a direct fiber connection adopting, you don't have great differences in terms of latency. We're talking about 1, 2, up to 3 or 4 maximum milliseconds of difference in terms of latency, and not for all the applications, but for most of the applications we are seeing actually this difference in terms of latency can be absolutely neglected. So this is just one example, one possible approach, and this is something that in team we are addressing. We are in the middle of this strategy of deploying this continuum of computing, and we hope that we believe it's the right way to go, and we hope you will appreciate it. It's a big effort, but can conduct to good success and good results. With this, I thank you all for your attention, but let me also say thank you to Dario and to Mirko and to all the people in Cisco and Links in Synesthesia and all the people that are behind this event. They have made a great job in organizing the event, in transforming, I believe, one of the first time in the world a hackathon in an online hackathon. It's really not simple, but given also the very difficult context we're all living, I believe they have built a great event, a successful event. So thank you, everybody. We really have appreciated all your effort. So thanks, everybody.
Thank you. Thank you, Andrea. Thanks also for your nice words. Let me tell you that this transformation from face-to-face to virtual event was, of course, let's say not foreseen. But since years we were thinking, oh, we should simplify logistics. Yeah, but we'll do next edition. And now we were obliged, of course, to adapt to the situation.
Yeah, that's absolutely true. We all hope that we are able to learn something at least.
Of course.
We need to look at the good things, and maybe
sure.
This will be the standard for the future. Who knows?
Let's see. Okay. So thank you for your contribution and presentation. Thanks so much again, Andrea. If there are any questions, as usual, otherwise I think Andrea is available and can stay a few minutes. And by the way, you are also invited if you want to join the final panel. It's your choice if you like. We of course, will be happy to have you on board as well. If there are no any other questions, I see already connected Faisal Zia from GSMA, that is the lead of the Operator platform, and will kindly provide a keynote and an overview of this Operator platform group in GSMA, defining the requirements for the definition of edge federation infrastructure. I think this is a very hot topic in the industry. I'm very proud and happy that we are collaborating here, and you expressed interest to support this hackathon. We did many things together, a great job together to arrive until here today. We have, I think, joint interests to attract developers, also in collaboration for the future. So my pleasure to have also Faisal here as a keynote speaker. Thank you.
Thank you very much, Dario. Bear with me just 1 second while I just share my screen so you can see that come up. Can you see that up on the screen now?
Yes.
Okay, lovely. Thank you very much, Dario. Yes, it's been a long road to get us this far, and I think that kudos to you guys running the hackathon. Been very well organized, and certainly pleased to be here today and join you for this. My name is Faisal Zia. I'm the Operator Platform Lead here at the GSMA, and I'm just going to take you through some overview slides of the Operator Platform Initiative. For those of you who aren't familiar with the GSMA is a trade association representing 750 mobile operators and around 400 industry partners from across the mobile ecosystem. We run initiatives in public policy, mobile for development, spectrum, IoT, and I'm coming from the Future Networks team. Alongside this, we also run MWC, so Mobile World Congresses, in Barcelona, Shanghai, and LA. Although COVID's been a friend to us this last 12 months, so we've now moved much of our events online. But certainly looking forward to 2021, where we'll be back with a bang. You can find out more information about the GSMA at gsma.com, but for the interest of today, let's get into the Operator platform, or ultimately Federated Edge Access. So what is the Operator platform? Essentially, it's a federated platform that allows operators to offer services and capabilities across a federation. What does this really mean? A one-to-many connection for the enterprises and developers to build once and deploy across a wider network. So ultimately, and I'll bring my mouse over just so you can see this on the slide. So ultimately, it's about the MNO platform. So rather than an operator offering edge services and capabilities within their own footprint, they're able to offer those services through the federation to offer more services and capabilities to those enterprises and developers across a larger network of operators. So, for example, we see services from MNO2 being deployed in MNO3, and similarly, vice versa. Now, in the operator platform, this is what Edge is going to be the first of many capabilities that it will launch. It's the first that we're going to be looking at. In future, we're also going to be bringing network slicing, IoT, network as a service. And these are kind of additional topics that we'll be adding to the operator platform as it stands. Now, within the operator platform project, we have two different work streams. So we have the operator platform project, which is looking at the technical framework. And we also have the Telco Edge Cloud initiative, and that focuses more on the commercial side as well as trials and POCs. But ultimately, it's enabling a federation across the operators to offer these services to enterprises and the developers. Now, why are we doing this? Well, ultimately, when we look at the 4G era, the reality is that a lot of operators are offering best service, best effort mobile broadband. And much of the revenue really goes up into the service provider layer. Now, in the 5G era, noting that the operators are going to expand their capabilities and services, if we add things like storage and compute, edge services, network as a service, network slicing, this increases the service offering for those developers and enterprise customers. And by leveraging those opportunities, this is the purpose of what we're doing with the operator platform, is enabling the next generation of applications, next generation of services that those developers and enterprises will be able to use. Now, one of the questions that we're often asked is, we provide this consistent infrastructure, a consistent interface for operators, but what about the hyperscalers? Now, the reality is that both of these solutions are going to be developed side by side. So this complements or enhances the hyperscaler solution. It's not seen as a either or. You have an option to do both. Now, when we actually look at the revenue opportunity that sits around this, we're looking at around about 620 billion. There are many reports out there that will point towards a significant opportunity. What I've done here is I've kind of looked at the different use cases that will apply, and generally you can see that this is really where a lot of the services will actually be developed. So primarily we see public safety, media and entertainment being the largest two, but that doesn't preclude other services from being developed as well. Now, in the operator platform, this is really the crux of the matter. What we're doing is we're defining a series of interfaces that will enable the federation to exist. So on the right-hand side, we have the OP, or operator platform, and we have the northbound interface, which is out to the application provider, application developers. And this is likely going to be a cloud-native interface, so it's already familiar with the interfaces that they use. On the southbound interface, this is the interface that's going to be plugging into the operator infrastructure, and then we also have the UNI as well. Now, the northbound interface and the southbound interface are quite well defined, and there's many organizations working on this. The difference and the delta is really around this east-west-bound interface, which is key to enabling the federation. Now, we take all of these together, and in the sum total will be the operator platform. But the reality is there's a lot of existing work that's going on with SDOs, with other open source communities. And what we want to do is really enhance, reuse those existing standard opportunities, and really build on those in order to make the operator platform a reality. The key thing here is about time to market, and that's certainly one of the key considerations in our initiative. How do we accelerate time to market for the operators? And also, how do we work with the developers in order to give them something tangible that they can work with? Now, as I was mentioning before, the operator platform group and the Telco Edge Cloud group, the operator platform group focuses on the technology side, and we have 30 operators, 20 vendors, involved in this side. And on the Telco Edge Cloud group, this is really focusing on commercial. We have 25 operators involved there. Now, I'm not really going to delve too much into the Telco Edge Cloud group. We've got a presentation later today from Juan Carlos, who is the chair of the Telco Edge Cloud group, so I'm sure he'll take you through a little bit more detail around the activity that's going on there. But ultimately, in the operator platform group, you can see who the operators are there, and you can see who the vendors are there. We've got around about 200 members now in the group participating, and we've just changed the structure of the group. So now we're going to be operating under AA35. What that essentially means is that because we are working on industry standards, we're going to be opening it up. So you don't need to be a GSMA member in order to participate in the definition of this work. We're opening this up, so if you're affected by the specifications in any way, you're welcome to join, and you can find out more details about how to join towards the end. Now, the operator platform is ultimately going to be enabling 3 different models that will exist. You have one side where the operator is going to be providing the total platform and will be acting as the platform provider. On the other side, you also have the role of the hyperscaler. So this really is talking about the different placement of where the infrastructure will exist. There's the item in the middle, which is the infrastructure provider, and this is really about where the operator platform will live. But ultimately, for the enterprise, for the consumers and developers, they're not so interested in how this infrastructure works. What they want to see is this simple, easy-to-use infrastructure that's consistent and allows them to leverage the power of the federated network. Now, in terms of current progress, so to give you an update, we had the operator concept platform white paper launched in January 2020, and then we've just in October 2020, just a few weeks back, we launched the commercial principles and also the OP technical proposal white paper. So what we're doing here is really kind of seeding the opportunity. Before we get to specifications, we want to get as much feedback from different SDOs, different developers, the wider edge ecosystem to capture their feedback and to get their inputs into what will be our requirements in Feb 21. And you can find all of those documents available at gsma.com/operator platform. Now, the reality is, okay, great, Faith, you're telling me a lot about these documents and specifications, but where can we actually get something that's tangible that we can actually use? And this is where we're kind of doing a pincer approach. You know, we need to, we're conscious of time to market, and we need to develop the specifications alongside the trials and POCs. Because in order to take those learnings from those trials and POCs, we need to ensure that we land them with our technical requirements at the same time. Quite traditionally, what we'll see is that specifications will be developed. After the specifications are developed, and we'll see trials and POCs, and then we'll see pre-commercial and moving towards commercialization. And that can take quite a long time. What we want to do is kind of develop the specifications whilst doing trials and POCs, and ensure that when we both land those trials and POCs, they land and the specification is already has trials and POCs that are quite close to the specification. That means that we can quickly move to the commercialization in the operator platform. So it kind of gives you an idea of the relationship that exists between the technical group and the commercial group. Now, on the 2nd or 3rd of December, we're going to be hosting some additional trials as well, so you can see the operators that are involved, the participants that are involved at this stage. We're going to be running essentially a matchmaking workshop, so we're linking the solution providers and the operators together. And we've got some example use cases of manufacturing, IoT, AR, VR, broadcasting, gaming, a lot of the edge use cases that we see already existing. And what we're doing is we're matching those services together in order to build trials in the future. If you do want to be considered as part of this, and it's building on the work from Intel, do contact us at futurenetworks@gsma.com, and we can certainly keep you in the loop for updates and future opportunities around this space. But ultimately, the trials and POCs will be helping us help inform our specification work, and it will be enable first mover advantage. Now, where are we at the moment? So we've closed to phase 1 in terms of the launch of the white papers, one on technical, one on commercials, and you can also see a catch-up available on our GSMA Thrive North America and APAC webinars. So this is all on our website. We've just kicked off phase 2 of our activity. So in the next release of our white paper and our PRD, we're going to be working with really those SDO and fora. Identify them, partner with them, and see who can help supplement the requirements and the standardization of the operator platform solution. Inevitably, there may be some gaps, so that's a question of how do we address, do we work with those SDO and fora, do we need to develop those in-house? There's a key exploration activity that will need to be taking place. We're currently developing concepts for those key topics, and also we'll be kicking off trials and POCs very, very shortly. Now, I'm not going to spend too much time on this slide. You will have it as part of your decks, but this is essentially the topics that we'll be covering as part of phase 2 activity, and you can see the owners of those different topics that we have there. We are, as I say, open, so if you do want to join and contribute towards any of these topics or any of these groups, do reach out to myself and the team, and we can happily get you involved there. In terms of a high-level timeline, so ultimately we're driving towards 2 key deliverables, and those are the ones that you can see at the bottom of your screen. So we've got the tech trials, and this is the second and third workshop, and following that we're going to be having lots of trials. And this really helps inform the work that we're going to be doing around specification development. So that will inevitably help us get towards our final objective of the operator platform PRD. In terms of Shanghai, that's going to be our next big event that we're going to be having. So we'll have an interim release of those deliverables and also touch on key use capabilities as well as feeding any inputs that we have and findings from the trials. So it's really around February that we're going to have the first drop, and then the OPPRD where we're looking to release the specification June 28th this year. To kind of recap, because I'm conscious there's a lot of information to kind of take in, we've got a symbiotic relationship that exists between the operator platform and the telco edge cloud group. And the trials are informing the specs, and the specs are ultimately informing the trials. Now, within that work, the operator platform group is going to be building the OP standard. So we want to reuse, supplement existing standards where possible, but also we're going to be running these pre-commercial trials and commercial trials through 2021. And by A informing B, B informing A, that's where we land these specifications. Ultimately, you've got the specifications, you've got pre-commercial trials, and then we would look to move to beyond the edge. So you're looking at services like network as a service and network slicing beyond that. The specs will be ready in June 2021 with those pre-commercial trials supporting. So those are the areas that we've been looking at. In terms of next steps, so an invite to join the operator platform group. You can influence the specification development and join there. We also have the tech trials and POCs, and you can reach out to myself and the team to find out more information on that. And then you can also track the activities on our website, gsma.com/operator platform. With that being said, I'm going to close there. I just wanted to leave a little bit of time for some Q&A to make sure that we can cover that off. But welcome to take those now.
Yeah, thank you. Thank you so much, Faisal. Questions from the audience? At least from my side, I would like to, let's say, express my comment. This is a huge group, right? So you mentioned more than 30 operators in the OPG globally and more than 200 members. Can you explain more? So you are now about to change some, let's say, rules in order to allow a wider group of companies contributing, even if they are not anymore GSMA members. Did I understand correctly?
Yeah, that's right.
Future? Okay.
So traditionally, we've been developing standards and specifications within the GSMA, and you need to be a member to support those. But we're transitioning towards something that's called an ISIG, so an industry standards issuing group, because ultimately the specifications that we're going to be working on will affect the industry. And so we're having a change in the terms to open up the group to not only just operators and traditional ecosystem partners, but also we really want to hear from the developers and really want to hear from the other players in the ecosystem, large or small, to help direct the efforts that we have within the Operative platform group. So you can see that 30 operators, 20 vendors. Dario, I'll be very honest with you. Every week I'm onboarding new operators, new partner organizations. It's a very, very hot group, one of the hottest in the GSMA. So it keeps me busy. So, certainly a great momentum and looking forward to carrying that through into 2021.
Cool. This is only a confirmation that you are doing well, I think.
Yeah.
Thank you. Okay, other questions? I see some stakeholders here in the audience. Don't be shy, guys. Let's exploit also the kind presence of Faisal, if you wish. By the way, he will stay in the panel with us. So at 5 o'clock European time, I will be having the pleasure to have you as well among the other panelists, and we can also further discuss about these things. Thank you so much.
Thanks very much, Dario. And as I said, we've got Juan Carlos, who's our tech chair. He's going to be speaking a little bit later, and we also have Shamik Mishra as well, who's going to be touching on a few points.
Yeah, from different angles, I think you all are covering well many aspects. Thank you. Okay, just ask you, maybe if you don't mind, Faisal, to stay connected at least and watch from time to time the chat window, just in case someone will ask some question. And if you stay connected, maybe for a few minutes at least, 3:30, sorry, in case of questions, okay?
Yeah, no problem at all.
Okay, so I don't know if it is too early. We can also make two things, or we make a break, 9 minutes, and we start on time. Or, Leo, if you need more than 30 minutes, I see Leonardo connected here. It's your choice. If you wish, we can even take a break, but if you need more than 30 minutes, maybe you can exploit.
Can you hear me, Dario?
Sure.
Up to you.
No, it depends on you how much time you need. If you need just half an hour, maybe we can take a break and convene.
I need how much time you make available. I can speak for half an hour, I can speak longer. You decide. But I think a break may be nice for everyone. Maybe we start on time.
Yeah. Let's take a coffee. I know that you have interesting things to say, but let's take a break, maybe 5 minutes break, and then we can start if you wish. I think it's also very appreciated by the other guys. We can take a break and refresh for 5 minutes, if you agree.
Yeah, I agree. Can you see my screen?
Okay.
Just want to test.
Oh, still not. You're about to start sharing, but still I see black screen, at least from my side.
Yeah, from my side as well. Yeah, black screen.
Yeah,
So the PC maybe is taking a coffee break as well.
Yeah.
Let's exploit this moment. Maybe Mirko, if you want, we can.
Sure, no problem. So let's have a break.
Reconvene, yeah, in 5 minutes from now. Thank you. Okay, so we are back to our afternoon session, and yeah, we are moving toward the end of this afternoon, the second day of the hackathon. This is the agenda. We have still 3 keynote speakers and then final panel discussion in parallel. This is the very last mile and the rush of the developers. Final delivery is expected today, 5 p.m. And then there will be only the public panel discussion ending the day at 6 o'clock. Of course, let me remind as well the celebration of the awards tomorrow afternoon. So now it's time to welcome Leonardo Gomez from Intel, 5GAA Working Group 1 Vice Chairman, MEC for Auto, Edge Computing for Automotive. Thank you. And stop sharing, Leo. The floor is yours. If you
pass me the ball, I think I cannot take from you.
Yeah,
no,
you should have it.
Let me know it's showing my screen.
Yes.
Okay. Let me see. Last time it crashed when I started sharing. Let me know if it's still working. I hope it's working fine, right?
Yes.
Okay.
I see the comment.
Okay. Good afternoon, everyone. I hope you're doing fine, and thank you very much, Dario, for the invitation to present here a little bit of the work we have been developing in the 5GAA, which is the 5G Automotive Association. We have there a work item that currently I am leading on behalf of Intel and the association. This work item is called MEC for Auto. So here I will show a bit of a taste of a very specific application of edge computing, and I hope you can enjoy, appreciate the perspective from 5GA and especially from MEC for Auto. So before I deep dive on the details of the work item, I think this was already presented by another colleague from Intel. This is a slide that you commonly see on edge computing presentations from Intel. So I may not need to spend too much time, but it's basically showing what is for us defined as edge computing, right? And also the definition, which is the placement of data center grade network storage closer to the endpoints. And we basically differentiate between the network edge, right, the typical MNO based edge computing, and on-premises. And the interesting thing is that in the case of automotive applications like in MEC for Auto, we can see both types of deployment of edge computing, right? You might have something like a typical roadside unit or roadside infrastructure, which would fall onto the category more like on-premise, right, along the roads. But you can also have services which are running on edge servers as part of the mobile network, for example. I'll not spend too much time on that, but I think it's nice to show our company's view. So let me start to discuss with you why at some point 5GAA decided that we needed a dedicated work item for edge computing, or as some would call also multi-access edge computing, or just MEC. This is already clear that edge computing is offering the cloud computing capability at the edge of the network, but the 5G Automotive Association considers that edge computing is one of the key supporting technologies for many V2X services, not only for connected vehicles, which are general vehicles on the roads, but also in the future of automated driving. There are some challenges, of course, which is good, gives a lot of opportunities as well for edge computing. And MEC for Auto is one of the first trials inside of the association to tackle some of those challenges, right? So I took here the high-level description or scope of that work item in 5GAA, which is, I took just a piece of it, which is basically saying that the target is to demonstrate the use of multi-access edge computing technology for automotive services, also known as V2X. And an example would be that you have distinct automotive vendors that are testing a couple of use cases. We just mentioned here at least 3 use cases involving distinct mobile operators and employing also network infrastructure provided by multiple infrastructure vendors. This is a, let's say, ultimative target. Doesn't mean that the work on the work item is only to provide this, is to develop the tools and the architectures that would allow to do this, right? But this is only to have a concrete, target from the feedback received on previous events and previous experience and exchanges between the stakeholders in the 5G Automotive Association. This is very illustrative on a minimum expectation, right, from that work. And just to illustrate a little bit what does that mean, what type of environment are we expecting to see edge computing deployed for automotive service, right? Our first element you see is, of course, the existence of multiple vehicles, multiple vehicle vendors, what we call here multi-OEM. It's not to confuse with other uses of the acronym OEM. In this association, we typically mean by OEM really the car manufacturers. As you know, the roads have this fundamental interoperability problem that not every vehicle is built by the same vehicle manufacturer, right? So they have interoperability on the road. But that also extends to the communication, right? And then you have the multiple network operators. I think we saw a couple of presentations already today on that. But may not need to spend too much time on that here. And we have, of course, the multiple network vendors. Maybe we could say vendors in general. We see the elements here from road infrastructure, which are also part of this overall system. We have the service providers. We have the cloud providers. We have the app providers. We have vulnerable road users in the road. So it's a quite complex situation, right? So I wanted to talk a little bit about the different topics we have been discussing in MEC for Auto. The work has been 4 tasks. The overarching and the very first work stream we had was related to use cases, but not definition of new use cases, because in the 5G Automotive Association, we already have a broad definition of use cases, currently listing around 50 different user stories from all the different types. So we need to first narrow down on some use cases which are interesting to consider when using edge computing. So I will talk a little bit more about this and what use cases have been explored and reviewed, take into consideration that they are enabled by edge computing. We have seen the requirements, we have selected them. Then there was a second task or work stream where we started to study different deployment options, how to solve the overarching interoperability problem for the edge computing services for automotive, and also cover some topics on security and privacy. I will explain a little bit more details on that task. And a third one, we are looking at demonstrations that are being planned across the globe. I'll say some words on that one, not too much. This is an ongoing activity, which there is still a lot of also confidentiality inside of the association. We should not review for the time being, but you will learn about that for sure. The press releases later on, hopefully in 2021. And then there is another activity still going on business and go-to-market strategies. For that one, I still have no material, and also probably won't have time to go much into detail here. So we'll basically concentrate here on the use cases and the study on the architectures. So let's then dive in a little bit on what we did in MEC for Auto and what use case we have analyzed. So the topics that we covered in this first task, they involved first to review different sources for V2X use cases, and especially those which are enabled by edge computing. There are a number of associations that are already mentioned before today, and 5G itself has a broad data bank of use cases, as I mentioned. Then the next step was to list some criteria to select those use cases. I'll talk a little bit about that. Then we analyzed those selected use cases. And finally, the work contains also some lists of MEC APIs that are useful for those different use cases that can be employed to realize those use cases, and also some introduction on this conformance test specifications for interoperability. But it's just really an introduction of the topic. We will not cover that today. In the future, in a couple of months, you'll probably see this work published, and you can look at the details when it is public. So let me talk a little bit about which criteria were used in order to check the relevance for edge computing of the different use cases, right? So the main criteria on the very first one was actually related to interoperability in this multi-stakeholder environment. Like we said before, multiple OEMs, multiple MNOs, multiple vendors. And then there was the edge computing performance and the related KPIs. So we need to analyze how those use cases compare when they are realized using, for example, an edge computing architecture with the cloud computing, and what are the performance gains, what are the related KPIs. The good thing here is there is also broad knowledge in the community about what are the advantages, what can be done to achieve the necessary performance. Those use cases, they also have their own requirements. And of course, we can evaluate the KPIs to check if the performance is really fulfilled as they are required. And then we analyze the viability of demonstration, because it's also nice to talk about use case, but if those cannot also be later demonstrated in practice, they stay in paper. So there needs to be also an appealing to demonstrate and show how this will work in practice. And then finally, there was an initial analysis of the potential value chain and business potential of the use case to be selected. This was just, let's say, a preliminary analysis, because later we had a more dedicated task that went into detail of that. But we did an initial one just to help us to be sure the selected use cases make also sense when it comes to business and deployment in real world. So how did that work, right? We had on the top the use cases, and then we look at this, as I just mentioned, the preliminary analysis on business criteria and relevance, and then we look at the technical criteria and their relevance of edge computing for fulfilling those. And for that, we even developed a template in order to analyze each of the use cases uniformly. In this template, we talk about how the interoperability should work for that use case. We talk about some KPIs. Here, for example, it's mentioned the latency. There is a small analysis on security and privacy aspects of the use case. And then there is an analysis about what type of MEC service consumption the use case could implement, and some other criteria, like for example, the network capacity load saving by using edge computing instead of cloud computing, and so on and so forth. There are a number of other aspects which were analyzed in order to select those use cases. And coming to more detail here, what were exactly the use cases we selected and we analyzed in MEC for Auto. The first one is the see-through. The second one was the in-vehicle entertainment. Third one was intersection movement assist. And then the vulnerable road user protection, which has actually even 2 tests to work. And then we analyzed vehicle platooning. I'll go a little bit in more detail of each use case here for you. So for the see-through, use case, this is just a pictorial example, right? What typically happens is that one vehicle, which we typically call a host vehicle, is signaling another vehicle, the intention that wants, for example, to pass, and we call the second vehicle a remote vehicle. And then it's using the oncoming traffic lane is provided a video stream to show the view in the front of this remote vehicle, right? Basically, you want to see what the car in front of you is seeing, or maybe a couple of cars in front of you, right? Because maybe you have more than one car, and you need to know, or maybe even a truck. And MEC for Auto has explored how MEC could be beneficial for this use case. For example, one clearly advantage is that the typical implementation would assume that there is a direct short-range communication between vehicles. However, you have a number of things that need to be considered. For example, the encoder, the video encoder needs to be a standard video encoder, right? Otherwise, the receiving vehicle will not know, right? You have to discover whether the vehicle has this service or not, right? So MEC can be very beneficial here, provide a lot of information with which otherwise you would need to either negotiate or maybe is not available, and would surely help this interoperability, because if for example, those cameras of different vehicles might be using different encoders, but the edge node could be able to transcode this video stream to any other vehicle, right? So you don't need to have a full stack standardization of this video streaming from vehicle to vehicle, because you have the MEC in between, right? And you already see here that things like low latency are required. You also need a high throughput. That's why 5G is essential to realize this use case. And another advantage is that in this use case, if you use edge computing, the edge node may collect a lot of information that is contextual, and also information coming from other vehicles. So on top of the video streaming, you might get even more information about the vehicles in front of you, like the speed of the incoming vehicle, right? You may really have an augmented reality on top of this see-through that allows you to, as a driver, for example, to see much more information than only the video stream. That would be the typical case if it's a direct communication, right, between two vehicles. And yeah, I think that's it for see-through. And a second use case is in-vehicle entertainment. This might be, especially from the automotive stakeholders, not so attractive because it's not involved too much particularities of the automotive environment, but it's more on the quality of life for the passenger or driver, right? But still is a very interesting use case, because you can be provided entertainment, especially when we reach the level of automation that the driver might spend a lot of the time in the car without having to drive or to do the driving tasks. Passengers could be offered gaming services, for example. It could be used for online education, office work. And on top of that, by using edge computing to provide this content, you can embed also some, let's say, contextual information, right? That allows you also during the entertainment to know without getting extra or accessing extra displays, you can get information about the traffic. You know, a lot of information can be overlaid on the environment, on this region where you currently are. And of course, as always for those entertainment applications, the edge computing will provide the typical advantage that you reduce a lot the loading in the backhaul. You have a lot of information closer to the user. You have storage. So I think this is a quite well known advantages. Go to the next one. Intersection movement assist. This is a very interesting one because it may have many different possibilities. Let's maybe have a look at the example in the screen. Imagine this car is willing to turn left, and it cannot see the car coming on the forward traffic. So it might be assisted by edge computing, which is collecting information about the whole environment and be informed that there is this car coming, right? And again, here the edge computing can provide a lot of information about the overall traffic, the situation, so that this vehicle is getting a targeted warning and not everyone getting multiple warnings. So you can be very efficient. Let me hurry up a little bit. The time is getting short. Another use case we have looked at is the vulnerable road user protection. Again, here, this vehicle, for example, wants to drive forward and there is a pedestrian coming in. One possibility to realize that is that this infrastructure has some cameras or sensors which identify a vulnerable road user. crossing the street and then provide the proper messaging. Another possibility is that another vehicle uses its own camera to upload or provide a stream of video from what it sees, and then the edge computing will analyze this video stream and provide a message to the concerning vehicle. And then the last one is platooning has been analyzed, where edge computing can give a lot of support also in the contextual sense, in order to discover also who is the lead vehicle and how to form and to keep in the platooning steady state. It's not about providing all the information for the dynamics, right, to keep distance and so on. There could be still a combination of short-range communication between the vehicles in the platooning, but still you can have some support from the edge computing to provide an overall view. So much about the use cases. Let me dive in a little bit on the different high-level architectures we have been studying. Just very quickly, this study involved different topics, starting by a state-of-the-art overview of edge computing for V2X. Then we went into high-level architecture, which I'll show now. And then it studied also some deployment options for the use cases. It looked at interoperability, service continuity, and finally there is some security guidance. I'll focus here on the high-level architecture. I hope we'll be able also in a couple of months to have this work published. So there are three main scenarios we have looked in this high-level architecture. I will go into each of them, but just some general assumptions that were made. Basically, you assume that there is a client application running in each vehicle. This application needs to connect to the MEC application, so the server side, on top of the virtualization infrastructure supported by the MEC platform. I think this is a topic was already quite explored here. We assume, of course, that the MEC platform can belong either to an MNO or any third party. An important assumption is, of course, that all business agreements are in place between all involved parts in order to allow the vehicles to access the requested applications. You'll see this why this is important. So in this scenario one, basically look at the situation where both MNOs have access or have in their networks the MEC platform, and they also have the application. But of course, these two applications, which are in the different MNOs, need to be accessed by the corresponding vehicles which are attached to the corresponding networks. And this is one of the type of exchanges that need to be considered, and we have more details in the work from MEC for all. In the second scenario now, although both MNOs have MEC platforms, the application is running on only one of them, so there is a need of this car attached to MNO B to access the app, which is running on MNO A. And the third one is the one where basically the MNO B has no MEC platform at all, and it needs to access the application and use the MEC platform of MNO B. I think for most of you this is pretty straightforward to understand. So just a final word on our demonstration activities. In MEC we are considering demonstrations on a global sense, meaning that we are looking to demonstrations in US, Europe, but also in touch with local organizations in China, potentially also Japan and Korea. And here you can see the targets as mentioned before. That's pretty much it from my time. I just can close time here. Thank you very much, and yeah, I hope you enjoy the presentation. Dario, I cannot hear you.
You're in mute, Dario.
Sorry, double muted as often. Thanks again, Leo, for your presentation and this great talk. If there are any questions, otherwise, of course, Leonardo will be part of the panel discussion at 5 p.m. in 1 hour from now. So we will have also other opportunities to discuss these topics also with other speakers.
Thank you.
Okay, thank you so much.
Thank you.
Okay, thank you so much. Now let me welcome Juan Carlos Garcia Lopez from Telefónica, who is the next keynote speaker and who will present Telco Edge Cloud Task Force. The presentation will provide an overview of the Telco Edge Task Force, including the trials deployed with many operators and partners. The speech will also explain how these initiatives are important for edge application developers in the ecosystem. So welcome again, and thank you for attending this hackathon event. Thanks, Juan Carlos. The floor is yours.
So thank you very much, Dario, and thank you for Droidcon and all the organization of this event for the honor to have me here to tell you a bit about the work we have been doing at the GSMA on the Telco Edge Cloud Task Force. I only want to say that this is a collective effort of 25 operators that have been working along the year in trying to give a push to these edge computing services in the industry. And well, just as an introduction, telling you that I'm Senior Vice President of Technology and Ecosystems in Telefónica, and also the Chairman of this Telco Edge Cloud Task Force. I would like to start just giving you a rationale on why we decided at the GSMA to launch such an initiative. No? When we look at what happened in LTE, the operators were playing a role of basically a connectivity pipe that was connecting the user with services that were built over the top. No? There were cloud providers that get to have a programmable computing environment for service providers to develop applications. And I think this helped very much these cloud providers to get a significant amount of the business that was built over the top in the network. Now with 5G, it comes the opportunity to deliver another kind of applications that are more time sensitive, privacy or security sensitive, and that will be deployed closer to the customer, to where the customer is. And it is a chance for the operators to evolve their networks with 5G to programmable networks that can open their capabilities, both in network and computing, to third parties for developing services. So this is an opportunity to capture the next wave of cloud services and applications that will be developed at the edge. I don't want to tell you a bit the expectations from the industry analysts, including the GSMA, on the revenues that are coming from edge computing. You may believe them or not, they are to come, okay, and we are all working hard to try to get a piece of this cake that looks like it's going to be big. And concretely at the GSMA, we started by the end of 2018 with this and working along 2019 to deliver something where we expressed this idea in January 2020. That was the operator platform concept. It was a white paper where we stated what the operators wanted to do to make this network, this programmable network and computing available to third parties for development. At the beginning of the year, after launching this concept white paper, we decided to split the activity in two streams. No? One, focus on developing the technical framework and working with the standardization bodies and open source community to define the technical architecture and the reference implementation for an operator-based telco cloud. And And here we have gathered a good amount of energy in the industry with 30 operators and 50 technology providers, as Faisal already introduced to you. And in parallel, we launched a task force, the Telco Edge Cloud Task Force, that has gathered 25 operators, also from almost all the regions in the planet, a good representation of the operator community, NSA, that has been working to prepare the launch of the service. And this means defining the kind of services that operators will offer and the commercial and business models to follow. In both cases, we have delivered in October the papers where we are summarizing all the achievements up to date. And I will explain you a bit the progress on Telco Edge Cloud. Okay? So that's the concept, no? The concept is preparing a platform to allow customers to develop, deploy, and manage edge-based solutions over a global footprint. The intention is offering a digital one-stop for these edge computing services so that the customer or the application developer may need to interact with just one of these providers to get access to the global footprint. We also define a fair and transparent commercial model that allows across the value chain, that allows each one to receive a compensation for the contribution to this chain. It is also relevant that the solution is based on open source and cloud and telco standards. So basically, Telco Edge Cloud is not defining new standards, but relying on the work done by MEC, 3GPP, TM Forum, and other standardization bodies. And also all the open source work on the cloud world with the Cloud Native Computing Foundation and other organizations that have already developed the cloud technologies. We are offering a simple interface and facilitate the creation of this network through open and standard federation mechanisms that I'm going to explain to you. We have got together a group of 25 operators that are representing a good part of the operator community in Europe, Middle East, Asia Pacific, and the Americas. We are not delivering, I would say, special services, so we are basically aiming at providing infrastructure as a service and platform as a service solutions. Two basic ones: we don't want to replicate the sophisticated environment of hyperscale cloud providers with a rich ecosystem of functionality. So that is not the intention. But what we want to do in a second phase is to add on top of these basic computing services also network as a service functionality that will allow the application developers and customers to program certain network capabilities in the radio, transport, and access network. And I'm going to explain you a bit what is the challenge of the creation of this network. And the ways operators can deploy an edge computing platform. The first solution is basically taking care of all the stack, providing the facilities, building all the infrastructure, building a storage on top, and then the platform that is managing and exposing all that capability. That is an option. Another option is to partner with an edge computing specialist that provides the platform capabilities, and in this case, the operator provides just the edge computing infrastructure, the servers, the storage, and the network. And the last option is rely on a cloud service provider, provide the facilities and the connectivity, and let the cloud provider bring all the compute, storage, and the platform. Okay? All these are models that are not theoretical. So are models that operators are implementing at this moment. Okay? The challenge at the GSMA was defining a common northbound interface to the customer, no matter what was the solution the operator has decided to implement, either on its own platform or through a partner. Also facilitate the interconnection to these platforms in a standard way. And finally, defining the east-west-bound interface to interconnect the different edge computing solutions, both being single operator, multi-operator, or based on address. And this is the scope of the operator platform group. that is aiming at normalizing all these interfaces. Aggregation was one of these federation options, or ways to make operators collaborate, work together, and offer a global service. And here the role of the edge service providers was defined. Okay? As simply aggregating infrastructure as a service services and build on top or negotiate on top agreements with service providers that could bring their own multi-cloud environments and middleware solution for specific verticals, or providing also a platform as a service service. Okay? Both A and B are not exclusive, and the edge service provider could provide both services. In all cases, you can see that operator can act as a sales channel on top, so delivering, selling platform as a service, infrastructure as a service, or a combination of both. And the other mechanism that Faisal already presented was the interconnection. Okay? There is westbound interface to interconnect either single operator platforms or multi-operator platforms based on edge service provider aggregate. We also define the role of the edge interconnection hub as a way to interconnect one operator or edge computing platform to many, to the rest of the global network of edge computing. And we must say that we have not been doing this alone. Okay? So operator platform and telco cloud has been open and collaborative ecosystems up to now. We have had contacts with many different associations and bodies in the industry, of course with the MEC and 3GPP on standards, but also on open source communities like Linux Foundation Edge, Alternative Computing Foundation, or Linux Foundation Networking, with which the GSMA set up the CNTP task force. Also, we were in discussion with several industry associations capturing requirements for the definition of our platform, and also offering them our infrastructure as a testbed for their trials. And all in all, we have been very active in the industry trying to set the reference of operator-based telco cloud services. And I want to tell you a bit about a number of trials that we have run during this year. So one of them has been a trial based on mobile extended reality gaming. It was run with Deutsche Telekom and using as a platform Mobile HX. We developed this with a partner that is Slavic Monsters that provided the Mythical Wars application. Really, the beauty of this trial was not so much on the virtual reality. You will see now in a video what was this about. But it was more on the kind of work operators can do to improve the edge computing experience, especially controlling the latency for certain applications, where a stable latency is probably more relevant than a low latency. And it was the case of this mobile gaming application, in which we achieved a stable latency of less than 30 milliseconds locally, so in Spain and in Germany. And we could establish also gaming sessions between players in Spain and Germany with a stable latency around 100 milliseconds. It was not a fantastic low latency, but good enough to have a good gaming experience. And the beauty of this was that the latency was stable, so the jitter was under control. And probably we can see now the video about this trial.
The edge computing potential for operators is really huge. We see great potential when it comes to consumer or business applications because the devices that we're using, be it phones or be it glasses in the future, the cars or drones, they need to have a kind of offload compute capabilities. And here, the closest part to the devices are the operators, and that's why we have great capabilities, be it managed latency, very good throughput, or be it a low jitter. But very important is that we act as a community. We have to act fast as a community to make these capabilities available to product partners in the enterprise segment and in the consumer business.
The GSMA Telco Edge Cloud Tech is a global platform solution to expose, manage, and market edge computing resources and capabilities across different networks and national boundaries, based on a combination of open technologies and telco standards. Tech is the only edge initiative targeting a global, open, and federated solution. Trials involving MNOs, customers, and ecosystem partners are essential to explore, validate, and further evolve the Telco Edge Cloud service. This was the driver behind Telefónica and Deutsche Telekom coming together with MobileEdgeX to demonstrate Telco Edge Cloud service. In this case, the service was a latency-sensitive XR game.
Spontaneously said, okay, my son is a good gamer, and I said, okay, my son is a good gamer as well. Why don't we play at our homes? Family versus family.
In this multi-operator MEC deployment, we were both connected to edge nodes, cloudlets in Germany and Spain, respectively, where the MobileEdgeX platform was running. DT and Telefónica provided the public network connectivity between the user devices and the respective edge locations. And as well as having fun with XR, we were able to validate the value of edge computing for a differentiated XR gaming experience.
We're sitting across Europe in different locations and the latency was so stable, as if you were in a local desktop environment.
The Telco Edge Cloud will be open and inclusive, and will support existing platforms like MobileEdgeX to accelerate the development. We will continue our collaboration with further trials as we build the Telco Edge Cloud in 2020.
So to me, this is really a highlight, and low latency compute capabilities from carriers are available right now.
Okay. Well, I would like just to tell you that this video was recorded during the most difficult moments of the lockdown. Okay? This trial was expected to have been run in our flagship stores in Madrid and Berlin, with the participation of customers and different people in these shops. We had to change our plans and run the trial at home, and we have even to use our families as cameraman, as actors and players in the video and also in the trials. But this is just I would say an anecdote, and I would like to really the essential part of this, as Alex Lutz from Day2 Telecom explained in the video, was the control of the latency. That was really the important part of this experience. Okay, can you see the?
Yes, sure.
That was the important part, the control of the latency and how the experience was offered to the application developer. The feedback we received from the developer was that, in fact, they wanted to have this controlled network performance. Was very important for them, but I think operators we still need to do a significant amount of work to make this network performance control something programmable, okay, and something that directly through an API or an interface the customer can request and get as a service on demand. Okay. Here we have to do some manual work, but the intention, as you will see in the future, is that all this stuff is something that our customers can do directly programming over the network. The second trial that is currently ongoing, as well with Deutsche Telekom, and in this case happening in Germany, in a city in Germany, is about collision warning. It is somehow testing one of the scenarios that Leo presented in the previous speech, that was the interconnection of two MEC hosts from different operators where the applications are running. Okay. In this case, we have on one side Deutsche Telekom Cloudlet with the application, collision warning application installed on top of mobile checks technology. We have our Cloudlet in our edge node, also in Germany, with the same application installed. We are serving one of the users that is a subscriber of Telefonica in Germany, and Deutsche Telekom is serving another user to its network on its computing application. In this case, the application instances for collision warning need to communicate, to connect to each other, to exchange the location and trajectory data of the two users, to identify the possibility of a collision and warn accordingly to the users. So this is somehow putting in practice one of the scenarios that Leo and the 5G Automotive Association is asking operators to deliver. And I would like now to tell you that we are going to have next week an event between a number of operators from the Telco Edge Cloud Task Force and different companies to try to match and identify potential trials on edge computing for the next year. Okay. Trying to continue exploring options and opportunities, and trying to have the operators help the developer and application developer community in finally launching and developing this business on the edge computing infrastructure. For this, the operators are committed to provide the infrastructure to host the trials and bring the customers. And the participants are offering use cases that can become services in the zone to medium term. We, as Faisal presented, we have product partners that are covering a wide range of different edge computing applications and sectors and verticals, and also operators from many regions in the world. We have good representation from Europe, from Asia, Japan and China and Korea, Sintel from Singapore, Telus from Canada, this from the US. So in general, an event that we expect next week will be a success and beneficial for all the parties there. No? You're also welcome to participate in future events. You can contact the GSMA Future Networks program if you want to participate on this. And I would like to take the last minutes just to give you a view of what is coming next. No? Faisal already expressed that after the first edition of the operator platform technical requirements, there was a new one coming next year, gathering the commercial requirements from the Telco Edge Cloud Task Force, and also the inputs from the different standard definition organizations with which we are working at this moment. There will be another editions of operator platform incorporating new functionality. This functionality is about network as a service, so offering this programmability of the network to our customers. And we expect that in the last phase of the operator platform that may happen probably from 2022 onwards, we will be having exposed as well capabilities like network slicing. Okay? And regarding Telco Edge Cloud, the expectation is that the task force becomes more operational, and derives into the launch of regional telco edge clouds around 2021. We have identified already 2 or 3 of these regional hubs that are going to happen this year. We will set up very likely at the DSMA a telco edge cloud forum to connect all these regional developments of telco edge cloud and to ensure the alignment and convergence in the future. And we will see probably a significant amount of pre-commercial trials with customers using the telcos. So all in all, as a summary, we have been working around the years in the definition of the telcos cloud services, both from a technical and commercial perspective, with the intention of offering application developers the opportunity to develop and deploy applications on a global footprint with an optimal and controlled experience in terms of network and computing performance, and over a secure and trusted manner. This is the intention of what we are doing. We have delivered the first document where we present all these ideas. We are moving now in a phase of execution in telco edge cloud with commercial trials with customers and initial rollouts in 2021. And as you see, there is a significant long roadmap in front of the operator platform group. It will have very likely a long life and plenty of extensions to this first phase in which they cover the edge computing part. And probably we will complement with network as a service, programmability of the network, and network slicing, so the opportunity of creating a full network on demand in the future. Okay, and well, that's all. We have now 25 minutes if you want to make any question.
Thank you. Thank you so much. Yeah, questions? So, yeah, I will be moderating the panel, so maybe I will, let's say, take some opportunity to discuss and give you some questions and discuss also with you and the other speakers. So for the time being, let me thank you so much for this keynote. Thanks, Juan Carlos. Thanks, Juan Carlos. Okay, good. So according to the agenda, we have the last keynote speaker. This is more, let's say, a technical keynote on a MEC Federation solution from Himanshu Singh from Altran. This presentation will provide an overview of the technical solution to implement a MEC Federation in a multi-MNO environment. So I hope this will also complement some other talks today, because some of us are well educated about this topic, other less. It's, I think, a good opportunity today to have this kind of heterogeneous set of keynote speakers. At least this is the intention. And for this reason, I'm very pleased to leave the floor to Himanshu, who will provide an overview and from their point of view of edge computing. Thank you so much again, Himanshu, for accepting the invitation.
Thank you, Dario, and thank you for having me here. It was nice to hear all of you, and I'll be presenting. I'll be touching upon, in fact, our point of view on multi-MNO federation and some related topics that we've been engaged in within Altran. So it's more like an Altran point of view, our engagements, and touching upon multi-MNO federation as well. Could you confirm, Dario, if you can see my screen?
Yes, sure. That's perfect.
Okay.
Thank you.
Thank you. Yeah. So let me begin. So these are the topics that I intend to touch upon. A very brief touch upon the various perspectives of edge computing, the various edges that the various types of edges that could be there, the kind of connections that those edges may need, and so on. a bit about distributing of edge computing services, about federation, the need for that, and so on. A couple of slides about Altron, in fact, one slide about Altron point of view on standards, very briefly touching upon the various standardizing bodies. What are the initiatives ongoing and how we are involved there, or what is our point of view based on that. A couple of slides about our edge computing platform and squads, touching upon the interesting topics that are related to telcos that we feel are relevant for edge computing, and a few slides about our engagements in GSM OPG, the operator platform group, which Faz talked about earlier. Our engagements in this forum called multi-operator MEC with multiple operators, and a bit about a type of edge called roadside unit, which is another, let's say, variation of the network edge that we otherwise mostly work upon. So these are the topics that I intend to cover today in the session. So to start with, I'll just briefly grab a pointer. Briefly touch upon the various edges that are there. It's a bit like on the slide that Leo presented, but I would like to just mention a few things about what are of interest to us. So for example, if we talk about the different types of edges, so a very high level classification would be a device edge and a network edge, right? And within the network edge, there could be distributed clouds, so on-prem clouds that the telcos may have, or those edges may be what are typically called far edges that may have slightly different requirements. For example, they may not have as much compute as a centralized edge might have, and they would be distributed across a telco infrastructure, say at aggregation points, or even at, if possible, at RAN sites and close to those. Then within the network edge, there are, there's a category, let's say, or a subdivision of that, which might be called an on-prem or an outdoor edge. Something like a roadside unit, something like that is providing services to a private deployment like an enterprise or a factory and so on. And the considerations of how these edges are built would be slightly different or are slightly different from how typically network edges are built, which are typically either data centers or micro data centers. Right? In an on-prem edge, you might want to have things like you might want to provide services that might host, apart from the edge computing services, also the network services, as in a private network, which means that a private 4G or 5G network, which means that it may need to host certain specialized hardware, which should provide compute services to the radio access network or such functions running on that edge and providing that private network within that enterprise or factory and so on. On the device edge side, typically what are called device edges are devices which intend to have or try to have additional compute within them so that they can do part of the compute within them. Anything that is related to analytics or anything that that is related to the kind of service that the device is trying to provide. For example, a virtual reality glass that might be called a device edge because it hosts quite a lot of compute within to provide that virtual reality experience and so on. But there is also an evolution in this device edge category wherein certain devices and applications hosted on those devices would want to have this capability that they can decide what part of the compute they may want to run within the device and what part of the compute that requires additional computation or such things they can try to offload to a network edge. So this is kind of like a transition from a device edge to a network edge, and also a collaboration that the application hosted on the device is trying to do. And there are certain manufacturers of, let's say, virtual reality reality or augmented reality glasses who are exploring possibilities. And also other devices who are exploring possibilities on how we can, let's say, create mass market devices by minimizing the amount of compute or battery requirements or storage that the device would need to have, and how we can offload much of that compute or storage to a low latency edge, either an on-prem edge or a network edge. Then if we talk about the applications which typically would be hosted on top of these edges, so ideally in an ideal environment we would want that the applications from the application provider point of view run seamlessly. So it's like build once, deploy anywhere, irrespective of what type of edge it is going to be. Of course, there may be some logic within the application that may want to exploit. For example, if it is an on-prem edge, then there may be certain specialized applications related to, say, if it is providing services related to RAM or core. So they may want to exploit certain capabilities within that on-prem edge, but for standard generic applications, they may want to run seamlessly across all the edges. So whatever platforms we are trying to build should be able to provide this kind of a capability. And then an additional note on certain enablers for the applications, which are typically called SDKs or APIs, or plugins. So we hear the term edge-aware applications and edge-native applications. And the idea here is that going forward, as edge computing becomes more prominent, we would want to have applications that know, applications running on devices that know that they are trying to consume certain services from an edge, and hence they should coordinate or collaborate with the edge computing platforms. So, for example, to access the optimal network endpoint of this application that is running close to this device, or that is running at an optimal connectivity point to this device. They may also want to collaborate with the platforms to instantiate their network endpoint running on the edge, so that we could have this kind of paradigm that a device can control when its twin that is running on the network side comes up and goes down. So when it starts and when it stops and so on. So just to enable this kind of a paradigm that while we deploy edges, they may not be like large data centers like public cloud or central clouds. So this kind of a paradigm where we can optimize which applications run when. So when do they start? When do they stop? When does the device need them? And which applications run where? So where does the device need them? So all of those can be enabled by certain SDKs. Then another topic of interest for many in the edge computing domain is network awareness. By network awareness, we mean that, especially in the telco context, how can we create platforms that can expose certain network capabilities or network information either towards the platform or via the platform towards the applications. So this is another capability that we've been trying to explore, and I'll speak a bit about this in later slides. And of course, edges can be deployed for serving various kinds of use cases: standard consumer use cases, industrial use cases for process control, process optimization, automotive use cases, the interesting use cases that Leo touched upon, energy and utilities for oil exploration and such things, or smart meters and so on. Rail infra, transportation, logistics, finance, public sector finance, for example. We've heard about algorithmic trading and how ultra-low latency is very important in certain financial scenarios. And entertainment, for example, providing access to content delivery networks and so on, so optimal action, or for example, the in-vehicle entertainment use case that Leo touched upon briefly. So that could also be categorized as this. The idea of edge is that it can cache content locally close touch upon in the edge computing domain. Then very briefly on how we see about edge computing as an extension to the cloud. So we have some clients trying to consume certain services or applications which are typically deployed on public cloud, and to use those services, clients often go through the infrastructure that certain operators provide, the edge clouds, the small clouds that the operators provide. And also we have certain clients which might be mobile in nature, which may move within a telco's domain or across telco domains, and they may want to consume services while consume the same kind of services while they move from one operator to the other, or they roam or they move within a telco's coverage infrastructure within a certain country or region. So. And then, of course, there could be certain devices which might be static in nature, but they want to consume services within that operator's domain. So the idea is that when we have this kind of a scenario where we are trying to distribute these small clouds, which we call edges, and provide services via multiple operators, we know that as these devices roam across, they access their connectivity services via multiple operators, but they should also be able to access the edge computing services seamlessly, no matter where they roam. And this is the concept that that we are trying to develop via this concept of multi-operator interconnect or federation, wherein and also something that Juan Carlos Garcia touched upon as a goal for the telco edge cloud. Moving forward, a key point of view from Altron's side on standards. This picture that you see is actually borrowed from a white paper from HC, which we also contributed to. So we are touching upon three different domains, let's say. So one is 3GPP, one is HC, one is GSMA Operator Platform Group. In 3GPP, there are multiple groups which are specifying different aspects of edge computing. There is the group called SA6, which we are also collaborating in the OPG domain. We had certain conversations with them, and which is introducing this concept of edge-aware applications, the concept of edge enabler client, edge enabler server, and so on, which is very close to the concept of edge, making the client sides of the edge applications aware that they are trying to run on an edge, or they are trying to consume certain services on the edge, and they would want to have certain APIs that they can use to optimally consume those services. So this is something that SA6 is doing, and this is also something very close to this user network interface, or UNI, that GSMA OPG is defining. Then there is this group called SA2, which is looking towards the mobile core interactions of MEC applications. SA5, which is working upon the lifecycle management and orchestration aspects of edge applications. MEC by itself has been a go-to standard or specification for a long time, and HC has also been working towards better adoption with the developers recently for what they are specifying and the kind of APIs that they are trying to propose. And then there is GSMA OPG, of which we are part of, which a couple of speakers in this event today have touched upon, which is trying to formulate technical requirements for the telco edge cloud concept that Juan Carlos Garcia touched upon, and working on interoperator federation, but also other aspects of how telco edge cloud services should be architected, or what kind of APIs should be created for various consumers or actors within this telco edge cloud infrastructure, or telco edge cloud ecosystem, I should say. So this was a very brief point of view on standards from our side. And very briefly touch upon our edge computing platform, which we call ENSCONS, and we've been also collaborating with Intel by integrating parts of their OpenNest platform and some parts of OpenVINO to provide acceleration capabilities. We believe that compute acceleration is a key feature for various use cases that people are trying to realize via edges. Compute acceleration may be related to radio access network functions for things like on-prem edges. It may also be relevant for various use cases where analytics or machine learning algorithms are trying to offload or trying to utilize that compute by offloading certain compute from the device to the network. So the platform itself, very briefly, would contain or contains a central component and distributed edges. And the idea is that this distributed component is the one that would host the applications. It should also have the capability to, if needed, to host certain containerized or virtual network functions. And it should also have the capability to have certain metrics or other such properties of this edge. For example, what kind of compute it provides, what kind of accelerators it provides, how loaded it is, where it is located with respect to the geography or with respect to the network, and so on, to certain services which are present in the central component, so that the platform itself can make decisions on optimal placement of applications on the distributed edges that are out there. And on the client side, we have an SDK that the client applications can use to be edge aware, to enable scenarios like discovery, how to place my network endpoint at the optimal location, and how to, let's say, instantiate or terminate applications on the network side when needed. Very briefly, the service model that we've been working on for the platform. Some services related to network exposure, and I very briefly mentioned this in the first slide about perspectives or the many edges. So network exposure is a topic of interest for many, especially also because the network exposure function in 5G or the service capability exposure function in 4G is trying to expose certain services that applications could consume or that platforms could consume. So some services that would be of interest are locations of devices, how to configure or how to retrieve QoS or quality of service that could be provided to certain subscribers, how to consume or access mobility related events for certain subscribers or devices, and how to use slice orchestration. Similarly, on the client side, we provide or use services via that SDK that I mentioned, related to discovery, related to function as a service, related to certain measurements that clients can provide, in addition to network exposure APIs that can enable additional orchestration or such services for the platform itself. And then there is a set of federation management APIs. I haven't listed the actual APIs here, but this is something that is under development also in OPG, the GSMA Operator Platform Group, which is related to orchestration of applications towards other partner platforms. So one platform can communicate with other platforms which are also compliant to this specification, and related to how resources should be exposed from one platform to the other, how monitoring and such data can flow from one platform to the other, and so on. And of course, there will be certain developer management APIs related to how developers are supposed to consume the services that the platform is trying to offer. A bit on the network exposure parts. So I mentioned that there is this network exposure function that a mobile core provides, and it consumes certain services with the actual network functions, things like AMF, UPF, SMF, and so on. It interacts with that. Those are the functions. It acts as a proxy so that external applications or external platforms can consume services like traffic influence or event exposure or other such things to either make certain decisions within the platform or to offer these things as services to other applications or other platforms. In fact, there could be other enabling platforms on top of this MEC platform that might be adding some services which can provide additional monetization capabilities or opportunities to telco operators. And similarly, the APIs that this provides or the services this provides can also be consumed by this network analytics function to offer certain additional value adds related to analytics and so on in a telco environment. I would like to touch upon some initiatives or some engagements that we've been having from on-prem side. So the first one is this multi-operator MEC engagement that we've been having. It is still ongoing with multiple operators. This is something that we started a year back with the goals laid out like this, that we would explore the concept of federation, how multiple platforms deployed in multiple operators can coordinate for application orchestration, and they can provide a single, let's say, a pane of glass or a single interaction point to developers or ISVs that are in different regions that are associated with different operators in different countries and regions. And also how to enable smart edge discovery by devices, how to enable that the client side of the application can discover the optimal touch point or connection point based on certain parameters via an SDK or API. So how to enable these things. And the second key goal of this engagement has been how to enable or how to use mobility, how to ensure that as devices move around within a network or in the roaming case across networks, how do we ensure that the applications are still available to that device for consumption? So how do we ensure service availability within a network as the device moves, or availability outside of the network to a partner network, which is also connected by this federation? And also we are trying to explore how one platform can, via this federation interface, interconnect with other collaborating platforms. So if they also implement, they have their own, let's say, platform, but that partner platform complies to certain APIs, complies to certain ways of working, and there is collaboration between the two. So how can applications be orchestrated from one platform to the other, and how can they be made available to the subscribers of that partner operator, and so on. And the idea of this has been that whatever learnings we gather from here, we contribute back to GSMA Operator Platform Group, which we are also a part of. So whatever we have contributed, we have been contributing to the GSMA Operator Platform Group, trying to specify various architectural aspects, the interface aspects, APIs, and so on. So whatever learnings we gathered from that multi-operator MEC project, we use to contribute to this GSMA Operator Platform Group. And the findings from this multi-operator MEC engagement have been published openly in this GSMA Thrive North America event, where Shamik, Juan Carlos Garcia, and David and others, Basil and others, presented topics related to tech and GSMA OPG. Finally, the topics that I discussed in the slides before, so they were more related to, let's say, a network edge. And I also mentioned that edges could be, multiple types. So there's another engagement that we are working on. So this is with Intel, in partnership with Intel, where we are exploring, we are building, in fact, this kind of a roadside unit, which could be used for things like scenarios that Leo had explained for Net for Auto or other such scenarios. Also as an on-prem or outdoor edge to enable things like smart cities or other such things. So the idea here is that we have like a ruggedized chassis, like MEC in a box, which is having compute services, so which is having enough compute to run some applications, which is running also a platform that is the edge platform that is offering services to host the applications, to orchestrate applications, and so on. It is also having certain acceleration capabilities, wherein applications can use things like Intel's HDTL, which is having multiple visual processing units and so so on to accelerate certain scenarios. For example, certain scenarios wherein we need surveillance, we need to use certain machine learning algorithms to detect what is ongoing on a road, whether there's a vulnerable road user crossing a road and a car is arriving, whether there is an intersection which is like blind and a vehicle approaching that intersection may have a collision possibly with another vehicle that is approaching on the other side. So using visual compute and using those accelerators to provide services to these visual compute applications within this like a roadside unit or a box kind of a chassis, and also including because we are talking about MEC, so also including capabilities to host the mobile network component, some parts of the mobile network components itself. So, for example, the radio access network. So in this case, we are using Intel's FlexRAN, which is accelerated via Intel's FPGA, and also layer 2 and layer 3 as Altron's offerings. On top of which, there is also a distributed data plane, a UPF, that is taking out the local data to the applications within that. So all of this combined together in a single box, in a single ruggedized box running on what is called the Intel Sierra architecture to provide or enable such use cases related to MEC for auto, or related to smart cities and so on. So this is another engagement that we've been having, and find it very exciting to be enabling such scenarios. So at the end, key takeaways. So we touched upon multiple standards for MEC, so about 3GPP, various groups, what they are doing, about FC, about GSMA, OPG, and key interest areas in MEC today, areas related to federation, how multiple operators connect together and provide combined services towards application developers for hosting and distributing applications. How do we enable mobility and roaming for MEC applications? How do we ensure a universal northbound interface and developer experiences? How do we expose network capabilities to be consumed by other platforms on top of the MEC platform, or they can be consumed by other applications which are trying to build some interesting use cases? And how these exposures and MEC in general can possibly help in adding new monetization possibilities for operators, and how things like network awareness, so awareness like where a MEC is deployed, how to interact with the network exposure function to enable different kind of additional scenarios using location, using mobility events, and so on. So these can enhance the applications in a MEC scenario. So those were the topics that I had in mind today, and this is Himanshu Altron. Thank you.
Thank you so much. And Himanshu, I guess yeah, most of the people can recognize these are really hot topics in the industry currently. So thanks again for being here and providing us this very insightful presentation. And so I would like now to take the presenter ball, if you don't mind, and also thank you again, Himanshu. While I'm setting up my slides for the panel, I'm asking if there are any comments or questions for Himanshu for his presentation now. I would like to invite all the speakers the panelists that are, according to the agenda, invited here in this final session. Quite new for me to be remotely moderating a panel from a room, and also everybody connected remotely, but okay, let's communicate and find a way in any case. And so let me welcome Nicola Faronato from the city of Turin. We have actually a last-minute change. Unfortunately, Riccardo Scopigno is not is not being available to attend. Is not feeling well. Unfortunately, we wish him all the best to recover soon. And there is Eduardo Bonetto, Juan Carlos Garcia Lopez from Telefonica, Farid Singh, Take3 Innovate, Faisal Zia from GSMA, Leonardo Gomez from Intel, representing also 5G AA, and Shamik Mishra from Altran. So this is actually the final part of these 2 days. I'm quite happy if we look let's say at the past. When we started this adventure, we initially planned the hackathon in April this year, and then we had to change it suddenly in February, more or less March, all the plans and adapt, and this was made a fully remote event. Let's see if, as Andrea said this afternoon, if this will become a new normal or not, but in any case, it was mandatory for us to adapt to this situation. And now I have also the pleasure to have this final panel with these very relevant and high level speakers, and on a final discussion about business or opportunities offered by Edge Cloud for the automotive and other industry segments. You know, we had a set of talks more focused on the automotive, but of course the Edge Cloud is not only on automotive. In any case, this domain is very promising. Let's see how, when, and what can be the way of, let's say, providing services in order to have a business opportunities for this very huge ecosystem of stakeholders on Edge Cloud. So I ask if I can ask the panelists to switch off their camera, switch on their camera, and maybe to show them themselves, and if possible, just to show their face. And thank you. Okay, thank you for all the speakers here and the panelists. Quick way to find a way to be interactive, because we are of course everybody remotely speaking, not in a real panel on stage. So let's try to be more present, possibly interactive. It's a long day today, so we are all tired. So maybe a quick icebreaker. I would like to ask a quick, raise your hands, and if you agree with the following statement. And current biggest challenge for Edge computing between infrastructure provider and developers. This was a kind of a very old statement. I tried to push this concept provocatively. 1 year ago, it was in a conference, maybe Edge Computing Congress in London. This was known as chicken egg problem, right? So you have infrastructure providers, and at least 1 year ago, it was true. And you have operators or infrastructure providers. You ask them, oh, please develop and deploy edge computing. They can answer you, yeah, but I don't see a marketplace of application developers. And you go to the application developers, you tell them, oh, please develop an application for edge computing. Oh, yes, but I would like to, but still no server, no infrastructure there on edge computing. So this was the famous chicken egg problem. Just to I want to check with you if this is still true or not. How many of you just raising the hand you agree, and maybe you can tell also your more elaborated your opinion.
I don't know if it is just me, but I hear your voice cut.
Yeah, same here.
Oh,
just a little bit. Yeah, it's cutting.
I don't know why. I don't know what's happening. Can you listen to me?
We could understand, but the quality is not very good.
Oh,
I agree with one.
oh, I'm sorry. I don't know how to do better than that. So, can you read the question and tell me just simply by raising the hand? We agreeing?
Dario?
1, 2.
Well, I'm halfway there.
2, 3. Okay.
Dario, Mirko speaking. Can you hear me?
Mirko.
Yeah.
Yes.
Yeah, if I may add a comment here, so Mirko speaking from Cisco. I facilitated the hackathon and the webinar. I'm not the real expert here, but I'm curious to know if the gap would be just not between the infrastructure and the application developers. I think that application developers are just already there to develop applications, but it's actually business case that are missing here. So I'm curious to know from the expert what's their opinion here. Business case.
Good. So we have three people which are thinking it is still a gap.
Thank you.
And Mirko is bringing to the table also another big elephant in the room, the business case. Okay, let's discuss. Interesting. I just wanted to know who is not agreeing. What do you think instead is the biggest challenge? Sorry, not agreeing. You just stimulate for myself a question for you guys. Who is not agreeing on that? Maybe if you have a different opinion, please feel free to speak up if you wish or not. If you don't.
Yeah, this is Shamik here. So
yes.
I think there is something in between. Yes, the business case, as Mirko mentioned, is very important to have a working situation for edge computing to succeed. However, having said that, I think there is something in between that's missing. If you look back at how cloud succeeded, it was because the infrastructure providers in cloud actually set up systems and allowed developers to use them as sandboxes. And today there aren't many sandboxes provided by the operators, which is practically close to the users. So if you look around, there are very few sandboxes today for developers to actually try something out. That means that the infrastructure providers or the public cloud hyperscalers are coming in and providing some kind of solutions like Amazon Wavelengths of the world, which is in a way a sandbox for application development. So I do agree with the statement, but I believe there's a possibility of having something in between which will help develop both the ecosystems, the infrastructure solutions, as well as application developers, and that's currently missing. And also, just if I may add for another 10 seconds, each industry is different. You cannot possibly have an application developed for an industry, say for example for automotive, the same principles, same design patterns, same requirements will work in another industry. Each industry, the language of each industry is different. So I think it's also important to have forums like 5GAA and others who will sort of drive industry adoption. The more the industry adoption, I think we can break this chicken egg problem.
I have to agree with Shamik over there as well. This is why I said I'm halfway there, because I also agree that and just to add to what Shamik said as well, if you want to look at, and this is the way I look at Edge, I look at the way cloud made it successful, and then figure out what's missing, right? And just to add to what Shamik said, that the other thing that's missing, and you're right, there are developers who are waiting to do this. There's no sandbox, but there's also no go-to-market for them, right? You have to understand that the majority of development actually happened when there was some kind of light at the end of the tunnel. The developers not going to spend time on and I've spoken to developers, I've spoken to startups who started building, and they're trying to work with the telcos and big companies. And this, you know what they're telling me? They say, I don't have time for a science research project. You know, I'm running out of runway. I need to go to market. And I think this is one of the things that, you know, a lot of the hyperscalers are providing, the Amazons of the world, they're providing this go-to-market along with the sandbox for application developers. And it's becoming more and more attractive. And Dario, you're right. A year ago, you could go to, in fact, a year ago, we did meet at the conferences with Juan as well. And at that conference, or any conference a year ago, if you had to ask how many application developers or people who are developing applications to the edge are here, you would have one hand up, right? So I do believe that there's a huge disconnect between the edge ecosystem as we portray it with the telcos and, you know, even the cloud providers and things like that, and the actual application developers. And that bridge is, you know, is still there. And there are some ways by which, you know, some of the application developers are getting, they're getting to know about the edge. They're getting to know, well, you know, what can I do? And like, you know, like Shamak said, there are some platforms and sandboxes being made available to them. But, you know, till it's worth their while, and this is not a business case or a business model or an ROI for a Telefonica or for a Vodafone. This is for the developers. Right? So I think that's one of the keys that is also currently missing.
I also agree with the point of Tariq and Samik. So I think operators and other providers have shown they have the infrastructure and the capabilities to host edge applications and make them run. But what is missing is that these capabilities are made available in a programmable way and in the way that the application developers are used to do in the public cloud environment. Okay. Unfortunately, this public cloud environment still doesn't reach the edge, and in this environment, you cannot develop applications on the edge. So you have only two solutions to solve this lack of a platform or a sandbox, as Sami was mentioning. And one is including the edge in the public cloud provider environment, and the other thing is making the infrastructure of the operators programmable through a platform on top that, you know, can be used by application developers to run the applications. And this is precisely what is the scope of what operator platform and telcos are trying to do, to solve this gap, to break the chicken and egg problem and make available to have the first chicken in place. Because I think this is what we all want to have is a first chicken that some others can eat or use to bring UX to the edge, no?
Exactly.
Yeah.
I think you're absolutely right. I think, you know, from GSMA perspective, this is part of the problem that we have. You know, I could do the technology and we could do the specs. That's great. But the developers don't want to get involved in deep technical spec discussions. We need to find the right vehicle for them to be able to develop and deploy the services that they want to. And that's where this chicken and egg of, you know, how do we speed up time to market with the telco edge cloud group? And that's exactly addressing this chicken and egg problem.
Yeah.
Sure. So it seems that still, the situation is evolving from 1 year from now, and we see some light in at the end of the tunnel, maybe some more, even if there is still a gap. Let me just try to summarize what I captured from you. We still see also some solutions in between bridge there's two. So I tend to agree, have the same feeling and perception. So before moving to the questions more to specific speakers, I would like to let's say. Okay, now Nicola is not, unfortunately, is not with us, right? So there was Nicola from City of Turin, is the only speaker. Maybe if Mirko, you can check if he is having some troubles. If you can stay, if you can stay with the camera on, it's like a pleasure to have you. Also, Faisal, all the panelists. So I think we can share some questions. I would like to have based on your presentations today. You presented very nice keynote presentations. Oh, sorry. Let me minimize, move this. Okay, good. So that I present the list of panelists. And yeah, apart from Nicola, because I was upset also from his presentation, I just took some notes. I would like to start as well from you, Faisal, from the presentation on GSMA. It's a really amazing the job that you are doing, collecting together these operators in the ecosystem. And also, if you can tell us more, or at least repeat, because you presented you have some plans now. You have published some white papers, and then you have plans to progress more. How to as you mentioned, developers, they don't care so much about specifications, but you know, also you have to put together all the stakeholders and operators and vendors, all the ecosystem. So what are your plans, and also the next milestones that you foresee for the next future?
Yeah, thanks, Dario. You know, one of the things, I'm not a technologist, so, you know, one of the key things is I don't want this to be a purely academic exercise of we go and develop a specification. You know, we need to have something tangible in market as soon as possible, because that's what the developers are crying out for. So, you know, we've closed phase one, and we took a slightly different approach. We closed phase one, we've got the commercials out there, which shows the different models that can exist. So it helps seed the market in those commercial discussions. But it's also the technical piece that we released. Now, we could have put a spec out there. We decided to make it more of a white paper because ultimately we want to get feedback from the whole ecosystem. That's the first phase. Get the feedback, gather the feedback from the ecosystem, take the learnings from the developers, take the learnings from the trials and POCs that we're developing at the same time, and then really pull that together and put that into our specification. I kind of call it landing at the perfect bullseye. You know, we've got the commercials, we need to get the trials, POCs, and land the specifications at the same point. If we can do that, then that means that ultimately we've got a spec and we've got pre-commercial trials already in place in the middle of 2021. That means that we can quickly move to commercialization sooner rather than later, right? Because that's the challenge that we have. Sorry, go on.
No, good point. Let's talk later on about trials, maybe with Juan Carlos. I was also kind of curious before talking also with the speakers about your plans for next year. Do you have some plans for Mobile World Congress? Is going to be hopefully again face to face in late June. Do you have a plan to have a footprint as OPG group there? Something that you would like to tell us, or if, of course, you can disclose and not, let's say, reveal too much the surprise. Do you have some presence there as OPG and Mobile World Congress, something, activities that you have in mind for that for June?
Yeah, so I'll cover this one. You know, the reality is COVID kind of hit us last year. So, you know, cancelling the show meant that we had to do a lot more online. I think that for 2021, as you may be aware, we swapped Shanghai and Barcelona. So February is now going to be Shanghai, and June is now going to be take place in Barcelona. So what I've been doing over the last year is, you know, we don't have these big events that we can go and evangelize and go and talk about the work that we've been doing. So it's been regular drops along the way. We've had the regional series with GSMA Thrive coming up into Shanghai. What we're looking to do in Shanghai is really kind of give a state of affair and update to the industry on where we're at with the specifications, where we're at with the trials. Ultimately, that's going to build the story to get involved in the specifications. Because like I say, first mover advantage is going to be key in this market. If we've got the specs done, if we've got the trials pre-commercial already done, you know, when do you want to come up to the party? Do you want to join at the end of the initiative, or do you want to have something pre-commercial ready to go during 2021? And I guess that's the key driver that we've got. Barcelona, I'm going to say it's going to be an exciting show. I'd certainly love to share a little bit more. Hopefully we'll be there face to face. I'm hoping so, vaccine permitting. But yeah, it's going to be a big year for us next year.
Yeah, thank you. So I remember there was Mirko asking before about a business model. Maybe Farid, you can tell us more about this creation of business model for developers, because actually this was the discussion started before. You can advise on what's your view about that. Thanks.
Sure. So, and to be honest, like I don't want to kind of get people's hopes up, but this is a funny thing, right? So I'm an innovation guy, and I know of, or at least I look at technology the way I look at innovation for pretty much everything else. And the business model, the funny thing is the business model exists for people, for the organizations that are willing to take risks, right? And when somebody would have asked, I don't know, any of the unicorns at a particular time, that what's your business model, what's your ROI on this? They probably didn't have it. They probably made it up. I mean, I work a lot with startups, and I know that 90% of the time what the startups tell me is going to be, off by at least a few tens of percent, right? So the business model for developers, and this is why I don't get it. I mean, I've been working in the edge kind of space since 2016. And if I was to kind of go back, and this is again coming from what Shamik said, and I love that he started this and not me, I would just go back to what the cloud did. And the business model, the go-to-market, if you look at it, even the conferences today are covering the same topics 10 years ago were being covered by cloud conferences, right? So I think the business model for developers has to be made very clear. And I know Carlos, you talked about creating this first chicken. And I'm hoping that creating this first chicken has the clarity of some way by which developers get to know, hey, what's our go-to-market? What's the business model here? Are we getting paid for installation? Are we getting paid for download? Are we getting paid for instance? And the funny thing is, the question that I wanted to ask you, based on two things you said just before, what you said, like, hey, there's two options. We can extend the edge into the public cloud. And the other thing is we can build something else, right? We can make this infrastructure programmable for the telcos. And so my question to you is, why don't we just keep it simple with everything from go-to-market and business and extend the public cloud model onto the edge?
Yeah, that is the way.
Right.
It's a way. Yeah.
Because I always tell people, and this is me. I used to be at Telefonica as well, and one of us knows this. The funny thing is, people who are going to buy the edge are the same people who are buying the cloud. We just don't know it yet because we assume that it's going to be, there'll be different players in it. But in the end, the consumption of this, I would say probably 80%, is going to be the same guys, because this is how software developers consume infrastructure or platform or environment, and that connect is very difficult. You look at most major telcos in the world, they have really struggled to sell cloud on their own, like their own cloud. Right? Deutsche Telekom, everybody developed their own cloud after they kind of got left out of the equation. So when I say like what's the business model for developers, I would say it's best to keep it simple. It's best to kind of go with what they're really familiar with. If you start doing things like, you get paid by the amount of MB and the amount of RAM and the number of MIPS that are being used and the number of edge gigabytes that are going through, it's too complicated for them. And I think this is the key. Unless you can get
so
that
there should be also, trying to capture also your point. I think is valid. We should also take care of how to facilitate the work of innovators and creating also clear business model for them and developers and also startups. For this, in this perspective, let me make, let's say, a bridge to another curiosity, a question that I had for Nicola, because on let's say, acceleration, a connection with the innovators. You mentioned in your presentation that the city of Torino is being able to attract many innovators in the smart mobility acceleration program. You mentioned this Techstar that, by the way, was also a keynote speaker in the presentation today, with a European exclusivity until 2022. So are you planning to attract only Turin-based startup and innovators, or also European-based innovators? What are your plans to let's say, open up the ecosystem and to attract innovators from the city perspective? Because I think also city administrations can play a role, smart cities, as you said today.
Thanks, Dario, for the question. So just to get back to you, I start with the first question, the chicken and egg paradigm. I think that the city potentially can play a role also at that level, because, you know, in between industry and application developers, the city could be an enabler, not necessarily the only one, but could be an enabler, because of course a macro project, a macro framework of the city, and I'm thinking about the framework of Turin, a house of emerging technologies, could be a proactive approach that could connect the demand and offer of a specific innovation, like, for example, edge computing. So I can see the city of Turin really proactive towards this opportunity, and that is a first angle. Second angle is definitely we are looking for international companies, international innovators to come here. You have mentioned Techstars. So Techstars by design is scouting the best talent globally, thanks to Techstars network and the ecosystem. But also I want to add that just a couple of weeks ago, we have launched a very important new project here in Turin called the Turin Reshoring, which is basically aiming at attracting, in particular from North America, some brains in Turin as an R&D department of either Italian companies which currently have been set up in the US, or US or international companies willing to be part of the Turin ecosystem about mobility, but also about tech, emerging techs and infrastructure. So definitely, I think that in Turin we have a couple of very interesting perspectives to be supportive towards this goal.
Yeah, good. So in terms of collaboration, I was also stimulated by the fact that you mentioned as well, Nicola, the 5G AA, and this is also a panel on automotive. It's a perfect for me to bridge also, and this gives me also the opportunity to talk as well with other colleagues that are involved in 5G. But first of all, I wanted to ask you, because I know this association, this is that is important for them to establish a collaboration with the road operators and cities and governments and public authorities and neutral laws and so on and so forth. So it's a good thing that you mentioned the 5G. So now naturally the question is coming from myself. What are your plans to collaborate with 5G? That would be, I think, a great message if you have some ideas or plans. Thanks.
Well, the plan is, well, take into consideration that let's start from 2020. So our idea was to strengthen the collaboration. Then, of course, as you can imagine, we have been a little bit limited in the scope of 5G strengthening the collaboration with us, mainly due to the contingency of COVID, which for the city has become the priority number one, unfortunately, during this contingency. So second step is we definitely wanted to revamp this file, this dossier, because we definitely think that the present and the future of Turin, both short-term and mid to long-term, will be based on smart road and smart mobility. For this reason, 5G will be really a key partnership, will be really instrumental to make this trend being well taught by the city. So what I really would like to do is revamp the 5G AA collaboration, starting from at this point, most probably Q1 next year, and really be able to push towards a midterm planning with them, even if we know that next year will be very important for the city of Turin because there will be political elections, so the government will most probably change mid-year 2021. But of course, if we are able to set up the right track, it will be a great benefit to leave for whoever will come next.
Yeah, sure. Totally agree, Nicola. And also, I have the pleasure to see that there are multiple stakeholders here and also in the panel, but also as a keynote speakers, you may recognize most of them are also members in 5G AA. So let me also ask to Leonardo, who is, of course, a colleague from Intel, but he is also representing working vice chairman in 5G AA. So what is, from your experience in working in this association, can you tell us also internally, what is actually, since the association is working a lot for automotive service based on edge cloud, what is needed, what is still the challenge, what is still needed from the technical and ecosystem sides to enable a broader deployment, actually, because we are also talking about go-to-market.
Hi there, sure. Thank you for the question. It's an interesting one. And, I can bring really a bit of the view from the automotive perspective, right? I've heard with great attention and interest the analysis before, and also on your initial question, Dario, regarding the chicken egg problem. And I was trying to translate that on the kind of problems we see from, for example, 5G Automotive Association perspective, right? And I think in some cases you need to really look at the, let's say, individual industries or for example, the specifics of the verticals, right? In the automotive sector, what we see is that even the mentality of the automotive industry is quite different from the telecommunications industry, right? For example, a bit of our experience in 5G, I don't know how many here were following closely, although their companies are members, but we are since the very beginning. We are used on the telecommunications industry to work, for example, on a 3GPP periodicity, right? In 3GPP, you have new release of standards every, let's say, 1.5 years, and then the whole ecosystem around cellular communication is trying to follow this. The automotive works on a totally different timeline, right? They have a much longer cycles. They generally work on a very conservative way. And when it comes to the examples given before, especially for business models, and this can be easily extended also to the technology standardization. I don't think it's very trivial to look at what was done in automotive for the cloud services and translate that to edge very easily. Because if you look to what the automotive sector has done so far on cloud applications, it's not very simple to translate that to the edge, right? What I think is still needs to be closed, there is still a gap on how these two industries talk together or design the system together. That's something that 5G has been working tirelessly towards, right? How do we make each other understand what do we want to do? And for example, in the case of who's developing the application for automotive, if you look to the use cases I have presented in my speak, you will see that this is not something that you can expect to be developed by the same guys who are developing, apps on a smartphone, right? The vehicle manufacturer is really concerned if there is some sort of warning or something that will influence the way the driver is driving, and in the future even for autonomous driving, right? It will not allow any app in the car, right? You have restrictions. It's not like a regular UE. You know, if you take more, let's say, less conservative automakers, if you take, for example, Tesla, you see that still they have quite a pretty domain on the kind of application they allow to run, right? It's not like you buy a Tesla, and although it's very much similar to a smartphone, right? You have all the features and the display. It looks very much like a smartphone, but still all the applications you can run there, they are coming from Tesla, right? You cannot just download any app that anyone developed and then you get, you know, the features you need. You are pretty much binded to what your OEM is providing. And I don't see that this will change very soon. And then comes the second problem, right? If you now are binded to the OEM, that means the primary or initial provider of all the applications for automotive will be coming from the automotive industry, right? And now you need to have this running on all these nodes everywhere, right? And you expect to have the same quality of service everywhere, right? So we see here already an initial problem of coverage, right? And I think I'm very glad to hear the plans, for example, on places like Turin, because if you can scale things, you know, start small on a city basis or maybe some circuit where you can get the trust, you know, from the automotive industry and try to run the applications on the way that they are expecting first, then you may start to see things scaling, right? And of course, there are some gaps. We have seen a lot of discussion here on the standardization gaps that are being closed, right? And I think also just a final word on my view of how the business model could work, because I'm not really a business analyst or expert, but I do see that I don't expect to have a single model, and especially on the vertical industries, I think there will be different models also regionally, because the services in edge computing may be regionally also a bit different. I don't expect that the same model may work on European cities or European roads like in US roads, right? I do expect that we will see some different models. It will also depend on the players and how the stakeholders or the car OEMs, for example, and their ecosystems will work, right? So we could expect that there will be ecosystems inside of the ecosystem, right? And yeah, I think this bridges a little bit, yeah.
Thank you. Yeah. And so since we are talking on 5G AEA, can you say just a few words or so about what's your view, what can be the role of the standardization and industry associations to enable these business opportunities, and especially for the cloud, for the edge cloud, for vertical industries like automotive?
Sure. Yeah. Fundamentally, I mean, why do we need this standardization, right? The fundamental problem that standardization typically tries to solve is interoperability, right? You have interoperability of systems in the first place so that you have different stakeholders and different technologists can develop things which work with each other, right? Just to give you an example, in the autonomous driving field, which is, let's say, it's a very different area from what we are talking about here. It's not telecommunication. I'm talking about purely autonomous driving. There is already groups that they have realized, you know, we need to standardize a little bit the behavior of the cars. You know, otherwise, when I'm designing, you know, a designer of autonomous car want to have some knowledge about what to expect from the other cars in the street, right? So such that he can adjust his own behavior. So they have realized that they need to standardize some of the parameters, or the way at least they calculate some parameters for autonomous driving. Just to give an example outside of our, let's say, box, right? So standardization is about interoperability and expect that things will work together. The second part of standardization is to get the scalability, right? So that we can have scalable systems and different people getting their shares and open room for innovation. And to link that to the associations like 5GAA, as I already mentioned before, the first important role of organizations like that is to first bridge the two worlds, right? We have the verticals, the automotive in that case, telecommunications. That needs to be bridged first. And then we can also agree on the direction of the standardization. And one important information, one important thing that the colleagues here might be interested to look at, the 5G recently released a roadmap for the next 10 years for the evolution of vehicular to everything, or cellular vehicular to everything evolution, right? And in this roadmap, you basically can see that, you can get an agreement inside of such organization like 5GA on how to move technology and where do we want to go. And then you work together on standardization and the ecosystem, right?
If allow me to have a comment, I totally agree with this, Leo. Also from a technical perspective, very deeply, let's not underestimate how huge is this work to bridge together those two communities. I'm there in 5GAA since 2017. I know by experience how challenging it is to put together those two communities, starting from very different backgrounds. This never happened so far. It's a relatively less recent exercise that are doing the companies together. I would say also successful, but also very challenging. There was a lot of effort put. And also in the standardization, you mentioned the standard bodies also. 3GPP started only the enhancements seriously on the V2X from release 16, and then we have also now we are talking about multiple standard bodies, and also the industry associations here. I see the role. I agree with you. It's really translating from requirements from the vertical to real. What is the impact on the technology? And this happened never so far. It's a very challenging work, and let's say it's also very important. I think what you are doing with the other companies also here involved. I would say the association is huge, more than 130 members there. But let's talk about also for a moment.
Dario,
to move to another speaker. Yes.
Sorry, I just have I'm going to be a devil's advocate here, and Leonardo, thanks a lot.
Please, you're welcome. Thank you. Otherwise, it's just a monologue.
So I have. I mean, what Leonardo mentioned is quite interesting. And like I mentioned, I look at things from an innovation perspective. So it's quite interesting that you said that, hey, in the automotive industry, everything is like, there's life critical things happening in automotive. You can't just get app developers to come and build them. And the funny thing is, the current app developer for automotive, for Tesla, is Tesla. The current kind of leader in the electric market is a guy and professionals who have no idea how to build a car, right? And they're the ones who are defining what their standard is. So I wanted to just make 2 points. This is something that I hear a lot, and it's kind of food for thought for all the panelists. But if you look at major innovations, they always come from outside the core innovation vertical. So the innovation in cloud didn't come from data center, like the data center incumbents. It came from somewhere from an adjacent space. And likewise for AWS. So my hypothesis is yes, that in the short term, maybe because there's so much, it's a dark art of what a connected car needs to be. You will find that the number of app developers will be limited to who are currently already supplying to the automotive industry. But similar to when, and I know that you mentioned that this is not going to be app developers, but when the phone came out, it only had apps by Apple. And it had 8 apps, and nobody else was allowed to make apps for them. And then they opened it up, and even now, there's the reason why Apple has a huge kind of tight grip on what it takes to kind of get an app listed on the App Store and what that app can do. So I agree with you. Like mission critical stuff will still be held by maybe very strict regulation and probably even governmental regulation. But other than that, the car is going to become something that we don't dream of it today. And the second thing I want to say, which I kind of tell a lot of people as well, and this is because we talk about standardization, and I have all the respect for standardization, but we have to understand that today, if you go back in history and we see what AT&T did, AT&T basically did everything without standardization, and they said, okay, if you want to come and play with this particular size cell phone, you work with our standards. Right? And they kind of influence what the standards have to be in the future. So what I tell people is that the lifespan of all technology is becoming so small, and the fact that they're all becoming software, while standardization needs to stay there to keep the world, let's say, a sane and safe place, I always tell people, you have to be honest. It's far cheaper for somebody to hire 500 software developers over 6 months to adhere to a particular standard when they are the market leader. So today, if Tesla says this is the standard in the US, I can guarantee you all the other automobile association members might say, hey, this is not according to our standard. But in the end, they will try and adhere to the standard that Tesla or whoever the market leader is, right? And remember, the market leader got there without any, maybe they got a bit assistance, let's be honest. But I just wanted to put that from an innovation point of view. But that's I really enjoyed your point there, by the way.
No, I answer your point because actually this is introducing another element, right? So the other element is, of course, the edge ecosystem is not only composed by big players. There are also smaller players. They have to be attracted as well. Not always the standard is a good entry point for them. But still, let's move. Sorry for reconducting against the MEC and the edge computing because at the end we are discussing an important point, also technically very, very challenging, very complicated, complex on the MEC Federation. And I think this was also very important to be explained in the previous talk. I will and here, I have to say, in this case, I think we have also to deal with standards. Maybe not only, and I'm looking at virtually at Juan Carlos, maybe he knows that also dually can be important trials also or open source communities. But still, before talking about trials, I wanted to ask Shamik, because your colleague brought to the table this harmonized standard and about different bodies, so starting from ETSI, 3GPP, starting from GSMA OPG. And what is in practice from your perspective, meaning that how this is feasible, and if you can just, in a few words, explain better what means in practice from the perspective of a company like Altran.
Yeah, sure. Thanks, Dario. I kind of agree with what Farid had alluded to some time back, in the sense that are we going to be too dependent on standards in order to innovate? It is historically known that standards have always impeded innovation. The Googles of the world really didn't care about standards, right? And today, what they built as Kubernetes ended up becoming the standard. So in a way, certain kinds of innovation, particularly when you're targeting the large developer ecosystem, having standards is actually counterproductive. And many efforts in standardization for developer ecosystems have not really worked. Having said that, there are certain things that need standards. Otherwise, the business model won't work. For example, if two operators want to collaborate between themselves, and if they want to share their resources, share their innovation, share the way their business models, share industry knowledge, they would need standards. And that, at least in the sense that how two operators can talk to each other, for example. The second thing is perhaps a developer who wants to access an operator edge today. Now he builds an application, say for Telefonica, on a certain set of APIs and runtime, builds another app, and the same application will have to be changed for another set of runtime and API for, say, Vodafone, and then for the third and fourth. Now imagine a startup with 10 people somewhere, say in East Coast or in Mumbai or in say Tel Aviv, and if they have to like spend money from their own pocket to maintain these 10 applications, 20 applications, because everybody is doing something differently, that doesn't work. So there must be some minimum northbound or developer interface that needs standardization, definitely, because that's going to improve the ecosystem. So standards which improves the ecosystem. Apart from that, there are certain things which have been adopted well. For example, 3GPPs, certain parts of this, their standards have been adopted very well by network equipment providers, device makers, and others. They also need to perhaps start to think in terms of developers, how developers can use certain aspects of radio information and things like that. Today, if you expect a gaming application developer to use radio bearer information, he will simply refuse to do it. So it is impossible for them to, to even understand what radio bearer really means, right? So from that perspective, there is a need to harmonize standards which help the eventual consumer of these services, the developers, is very important. Standards which help build an ecosystem like multiple operators coming together. That's what GSMA is doing, and Faisal would be able to talk better on that. In OPG, for example, the whole idea is to build an ecosystem. For example, how we build a certain set of rules to build an ecosystem.
Sure. Thank you. I would like to bridge, you made a very valid point on the APIs. From a developer point of view, it's essential that they build their application. I would like to talk, not always, we always use the term interoperability. In this case, maybe it's more application portability, right? I don't want to have this kind of headache. I want to develop the app and maybe to sell it to whatever operator in the world, and without changing so much my code and my application. So interfacing and APIs.
Maybe I add to that. There's also there's a bit of a technocultural issue here. I know there are operators here, but the way things work with network equipment is that there are trials which goes on for months, 6 months, 8 months, 10 months, and then you do interoperability between two network equipment providers testing their stuff between themselves. It's actually good because companies like Ultra make money out of that, so that's not a bad thing.
Okay.
But if you look from a developer's perspective, a startup expected to wait for 6 months so that their application is accepted, that's not going to build you an ecosystem. So there must be a way to implement CI/CD pipelines, DevOps, use all the things which a developer are used to ensure their application is validated. Portability, as you rightly mentioned, as soon as possible, as quickly as possible. That's why the sandboxes are so important.
Yeah. So let me also have a question quickly, because as a comment to Eduardo, because in this perspective, Links Foundation was a great partner for this hackathon, and they were providing, together with the other partners, of course, some facilities for developers. And what we understood since the beginning, I remember the first edition of the hackathon in 2018, there was a guy, now CEO of a startup, that now they are growing. Even they were winning the first edition of the hackathon, and I remember in a press release he mentioned that yes, I like this technology, the MEC technology, the edge computing, but I want to understand how to use it. I need APIs, and then in fact what we are providing here for the hackathon developers is not only the MEC platform, the openness and all the toolkits, but also a MEC compliant implementation of a location API that Links has provided to developers. So I wanted to ask you maybe your perspective. How do you feel is beneficial? Which are, let's say, why is so important software environment for application developers? What's your experience on that? How is challenging, and then how are useful these APIs for the developers in the hackathon? based on your experience on the hackathon, but not only, of course.
Is that for me? Oh, okay. No.
Yeah, for Eduardo. Yeah, thank you.
Hello, Dario. Thank you. Hello, everyone. Yes, the API is very important for the developer perspective since it can access information. When we start to think about possible application exploiting a location API, we see the need to have something to test our application. So since no API were available, we decided to start to implement a simulation of the location API, and in this way we were able to develop some application to test it in some simulated but close to the reality environment. Indeed, the simulator can replicate exactly the environment that could be in a real MEC server. So for the location API, but also for other different type of API, a simulator may be very interesting for developers in order to start developing application, to test it and see if there's something wrong. This mainly because at the moment no such test bed for testing application is available.
Sure. So yeah, we are seeing, let's say, gradually more example of innovators popping up in this area of edge computing, and also part of the goal of these days is also to provide means and tools to educate, to share the knowledge and so on. Thank you so much, Eduardo. Just a question we were discussing before. Now, maybe we can also have some common question open to everybody to close the panel. But before that, I remember I just have a question I noted. I took note from Juan Carlos because I was attracted by his presentation. Actually, there was a slide as well from Faisal on the same GSMA. We are talking about a huge market on edge computing, and you know, often we see a lot of numbers about forecast and market forecast, and was positively surprised that one of the so edge computing is addressing different verticals. Now we are talking, of course, about automotive, and in fact, in your slides, automotive is a huge, let's say, slice of this edge cake, right? So with pleasure, I see a good synergy and with automotive. For your perspective, since you are talking about applications and so on, what is your feeling if you have some examples of innovators or better use cases or application in the automotive domains that you see relevant for your experience in the Edge Cloud group? Also coming from trials or for collaboration, just if you can give us some examples of use cases that you see relevant now in this period.
Okay. So first to note that the big figure that you could see on the slide, 122 billion associated to the automotive industry, are related to transport. No, that is a bit wider than just automotive.
Wider, yeah, sure.
But think that the car is the next massive thing to connect. So when we have 7 billion people in the world, we have 1.2 billion vehicles. And this means a massive amount of moving things to connect. And moving things to connect is the core business of telecom operators. No? So then it is expected that there is a big opportunity. And well, the cases so are many. No, the two ones that have been developed before 5G came have been basically related to connecting the car to extract data from the car for the car manufacturers. No, to have a kind of remote surveillance and maintenance of the vehicle. No? This is something that has happened and is happening. A good amount of cars are already connected for these IoT use cases. But I think the massive amount of money or of business will come from vehicle entertainment, and this will grow as cars become more autonomous, and the driver and the occupants have more time to dedicate to entertainment during the car, in the travel. we will see also a huge amount of business coming from fleet management and all the control of the track fleets for business, for companies, in order to control the processes of supply chain and distribution of goods. And like this, there are many use cases associated to automotive. There is, of course, one that we have mentioned a lot of times during this event, that is the assisted driving. So everything related to V2X and how we can help the driver in improving the safety while driving, both if the vehicle is autonomous, so it's driverless or with the driver. In both cases, that will help much. I think that the authorities have a strong interest in this, and the reason for this is that we have 1.3 million people killed on the road every year. This means one every 25 seconds, so it's much more than what coronavirus is doing. And the interest of authorities and public administrations on cases associated to automotive is high, so you can also find public funding on those cases very likely in the future. And that's why the figure is so high. So it's not a single case. It will be a combination of different use cases around the vehicle, and we have seen many in this event.
Thank you so much. Now we are moving toward the end. Actually, it's already let's say 6 o'clock in the afternoon. So I just wanted to bring on the table a couple very quick questions, if you would like, just to wake up a little bit. You can have a question for everybody and raise your hand. Maybe you can just take your opportunity. Just want to also to ask a question. Maybe also a provocative statement, just to react, and I like also when there is some more debates. Why not? So here's the question. My PC is assisting. Someone in the blog says 5G is in need of edge more than edge will need the 5G. How many of you agree with this statement? Just raising the hand. You feel free to disagree or provide any comments and so on. How many of you agrees or disagrees? One. Okay, yeah, not the majority. Two. There are two, maybe only two. Okay, 2 over 7. I don't know if Nicola is still with us, but still the minority. So someone is thinking maybe the edge computing is not that much in need of 5G, but more the 5G. So the majority still don't think is the case. Let me first of all open the floor for comments, or from one end or the other one. I'm not biased at all. I want to throw the stone in the lake and see what happened. So you tell me your opinion.
Maybe let me start. Maybe one of the reasons why I believe that edge is required for 5G is the transformation of the business model in itself. Because if the operators do need to monetize 5G, they would need an edge. Otherwise, most likely the whole ecosystem would continue to be the way it is today. Having said that, I think 5G is still in the search of what is the killer application. It's a question everybody asks, but I don't think that's really what's needed. There isn't going to be a killer application overnight. For example, 2G had SMS, 3G had data, 4G actually enabled you to hail a car from standing in a road. 5G perhaps is going to make things very different for things which move. For example, cars, people playing a game connected to an edge when they are maybe on a train. So the mobility aspects, if it at all has to be monetized today, there would be a need to have an edge compute. And that I think haven't been really monetized so far in 4G. the way things move from point A to point B, how people move, how material move, how in the case of pandemic, there are things which would move by themselves, like autonomously. And all of these things would, in a certain way, would be merging the need of a telecom operator to monetize 5G. And I don't see how that can really work without an edge. Of course, there could be other use cases where you may not need an edge, but a significant part of the mobility aspects would need edge.
Yeah.
Okay, good. Opposite opinions are welcome. Then, thanks.
Yeah, well, I want to add here that also, so what Samik said is true, but it is also true that deploying edge with 5G is a totally different game than doing this with 4G. And the reason for this is that with 4G or any other G technology that is not 5, you will need a significant amount of additional edge computing nodes. And the reason is very simple. You have a latency budget for a certain application, let's say 20 or 30 milliseconds. If you use 4G, you will spend a good part of that latency budget already in the access. And you will need to have the edge node very close to the base station. Okay? If you use 5G, you have in the access only 1 or 5 milliseconds, then most of the budget you can apply on the transport network. So this means that the edge nodes can be far from the base station. So the amount of edge nodes you need to deploy the same latency on 5G is significantly smaller, and probably an order of magnitude or 2 orders of magnitude smaller. So edge is much more economically viable with 5G. This is the first question. But the second is that there are some edge applications, the ones that require extreme low latency, below 5 milliseconds, that you will not be able to deliver on 4G. So you can deliver with a very close edge node to a 5G base station. Okay, so edge is facilitating much. It's facilitating much with 5G.
So I
good point of view. Please, Farid.
I just want to say, like, my point of view is like looking a bit more to the future. And this is historically looking at, if you look at all technologies from 2G right up to 4G, the life of each of these technologies is half. So starting from 14, 15 years, coming down to now, 3 years for 4G, right? So for me, the reason 5G needs edge is basically for the survival, or rather the removal of the whole concept of any more Gs, right? What the edge is going to provide the future of communication is the ability to make communication or the communication technology irrelevant. And you'll see this when this happens. You know, and a good example of this, most technology you see today is somehow portrayed in science fiction. In no science fiction has anybody said, open a 4G or 5G channel. Nobody says that. So what is going to happen is that edge will give the ability, and it's going to be the 5G, 6G, 7G, whatever is going to come up, the ability for applications to use communication bandwidth more realistically and in a more real time. And for the reasons that Juan said, that why this is important is the fact that you could possibly still do this. You could do this at the core. There's nothing stopping any of the telcos from doing this at the core and providing, better quality of service. But to do that at an application level, you require this to be intercepted somewhere between which is more efficient. So what I believe is that, with edge, 5G will become, I won't say irrelevant, but it will become, the number 5 will kind of disappear over time. Because this is really bad for the telcos. Every new generation means a huge investment for the telcos, and the ROI is not really that straightforward. So what we really need is the ability for the applications to get monetized, not the connectivity. And the connectivity, today 2G is perfectly okay for, most of, at least 2 years ago, most of connected, vending machines were all running on 2G, some on 3G. But, communication, the Gs are not, to me, as an innovator, the Gs will become irrelevant maybe 3, 4, 5 years down the line. And people talk about applications. And like Juan said, you'll have applications that require low latency, applications that require high bandwidth, and the Gs are going to become irrelevant. Because guess what? After 5G, all the other Gs will kind of be able to coexist because they're all software. You need some hardware stuff to change, but this is the way why I think 5G, needs edge more. Otherwise, after 3 years, there'll still be a big hole in the bank with 5G.
Okay, interesting. Running just one comment or question, and then otherwise we move to the last one.
Dario, if I may say something.
Very quickly. Thank you. Thank you. Yeah.
So I actually disagree with this statement because I would say that edge is part of 5G, right? Because 5G is basically from all these generations that colleagues were mentioning before, where we have a truly, let's say, virtualization even of the network components down to the radio access, right? And basically your radio access network is already become part of this, let's say, edge computing environment. And basically I wouldn't say that the two things are separate, but they are the same, right?
Indeed, this was a very provocative question, Leo. The nature of every kind of provocative question is really based on partial truth and partial.
Yeah, that computing and communication, as Farid just said, they will merge, and that's what we'll see from 5G on, is this merging between computing and communications in a way we haven't seen on previous generation. So I wouldn't separate both. Yeah.
Yeah. But by the way, I respect all the opinions. I think all of us has let's say their own opinion, and nice to see also different opinions. This is also nice when we organize a panel. It's very boring when everybody's agreeing on everything, right? So, thank you for your comments. Very last. I would say I initially was thinking, prepare yourself for 30-second answer. If you, because we were talking about chicken and egg and let's make a chicken, then I'm starting to be hungry. I'm thinking to the dinner. If you feel the pressure for the dinner, maybe you can prepare a shorter answer to the question, maybe also one sentence, and then we can close as soon as we finish the panel. So a very quick question, more open. We talked about edge computing market. Sorry, I'm projecting too much. Okay. Edge computing market is let's say we're talking about a cake, a big and variegated cake with many stakeholders, and we'll need a collaboration. There was a discussion about the MEC Federation, the Operative Platform Group, and different standards, and mobile operators, and hyperscalers, and edge service provider. So, how do you see a long-term collaboration between edge computing stakeholders? So, okay, you are free to be negative and talk about current challenges. I would prefer an answer, positive or negative, don't care, but more projected to the future. Future views about how you see possible, not possible, how a long-term collaboration in one sentence or few. Who would like to be the first one?
Me.
Carlos.
Yeah. Well, in one sentence, you will have to partner with other service providers, with the scalers, cloud service providers, and also with competitors, with other operators to get a piece of the cake. So I don't think there is a single party in the edge computing business that will be able to do on its own. And it will have to partner with technology and service providers from network, from IT and cloud. And the edge is a very complex task and will require collaboration agreements. The one that makes the best agreements will be the winner.
Good.
Yeah, I'll go next. In a way, I think without a collaboration, as I mentioned earlier, edge computing will not succeed. There are too many different stakeholders with different objectives, and all of them you would want to use edge computing to meet a certain goal. And there needs to be alignment. There needs to be a way that all of them can work together. And I think such organizations like GSMA or OPG is an attempt to try and streamline that kind of collaboration model. But I think the larger collaboration would be through open source or through some kind of model where application developers are also made part of the stakeholder process.
Interesting. Very quick, maybe last one or two other opinions.
I would say the simple thing would be to be transparent. So, I mean, there needs to be collaboration. This is clear.
Sure.
Everybody needs to be transparent, and people need to say what they want. The game that we're in, everybody wants to keep their cards close to their chest for the last 5 years, and not actually say what they want or what they're willing to give up. And the understanding, I've always ended all my talks with this. The pie is going to get smaller before it gets much bigger. So if you don't believe in that, then the Amazons and the Googles of the world will drop a few $1 billion, and we'll take the market. We'll take part of the edge market, and we won't even come to know. So in my opinion, you have to understand that you have to have if anybody tells me what's the ROI on this, you're already not talking collaboration right now. So honestly, my advice.
I think that's quite an important point that you raise about collaboration. And traditionally operators are very good at going in a room and going and developing a specification and then try and push that to market. And there's always a challenge about how that goes to market. This is why we've taken a completely different approach with OPG to say, let's bring everybody in, because this is really an opportunity to shape the ecosystem and build this together collaboratively for the interest and benefit of everybody together. And I think that that's something different in the approach that we're taking. Is open it up. Everybody's got a part to play. Everybody's got a revenue opportunity piece in this, and that's what we need to facilitate. I think the challenge that we have, as with a lot of initiatives, is fragmentation. How do we? My challenge: 30 different industry organizations, all working on edge, all working on different solutions. How do we bring those all together to say we need to have a consistent view to the developers? Because whether it's 5G AA, 3GPP, ETSI, does the developer really matter? He just wants to know which APIs that they need to consume in order to get to market. So those are some of the challenges that we're going to have to address in order to make this collaboration successful.
Thank you. Thanks so much. I think it's good to finish with this comment, and thanks also for the panelists to be here. It was a pleasure, a great pleasure to chat with you and to talk about the topics. Very interesting and insightful your presence here. Let me thanks again everybody and the organizing committee and all the companies, the City of Turin, GSMA supporting the hackathon, ETSI, and also especially thanks to Mirko from Cisco to manage all the WebEx facilities for this online event. And Francesco from Synesthesia is the host of the hackathon, but he's very busy in preparing the Droidcon for tomorrow. And this gives me also the opportunity to remind you this is not the end of the story. Tomorrow will be the celebration of the Hackathon Awards and the main Droidcon conference, so stay tuned. We will see some announcement there, and there will be the main conference. So thanks again. It was really a pleasure to be your moderator and also to be part of this great event. Thanks everybody.
Thank you to you.
Thanks a lot, Dario.
Everyone.
Thank you, everybody.
Thank you very much.
Thank you.
Thank you.